Hey, I'm Scott Roberts. I want to thank you personally for tuning in to watch the 114th Global Star Party. The concept of the Global Star Party started during the pandemic as a way for amateur astronomers and just those people interested in stargazing to interact during our period of lockdown. But we've also learned that there's a lot of different people in lockdown for different reasons. Some of it's just geographic location. You know, they're too remote or whatever to interact with amateur astronomers in a real-time live fashion. There's also people that are challenged in different ways that they're not able to attend live star parties. But we've had some amazing speakers on from around the world, and this is really the only way that you can have a star party in the way that we do it. So we get astronomers to join in via Zoom. We rebroadcast that out. We're simulcasting it to several social media sites, including Facebook, Twitch, Twitter, and YouTube. But tonight's the 114th event, and the theme is a bump in the dark. And we've got, of course, some great speakers. We have David Levy, Comet Discoverer David Levy will be on. First, we have Carroll Orge. Carroll is the president of the Astronomical League. We've got Dave Eicher, who's editor-in-chief of Astronomy magazine, who will be talking about his exotic deep sky objects. I think this one will be the Cat's Eye Nebula. Young Navin Senthil Kumar, who gives a nice presentation each time he's on. It's been a while since he's appeared on Global Star Party. We're really happy to have him back. Dr. Daniel Barth, who is heading up an initiative called the Eratosthenes Project, where people from around the world will actually do an experiment to measure the circumference of the Earth. Okay, this is something you can also participate in. I think you'll find it very interesting. Astrophotographer Maxi Falieres, who has shown our viewers how you can do astrophotography on a budget. He'll be broadcasting in live from Argentina. We've got space artist and astronomer John Schwartz, who's going to show us some of his latest work. Dr. Marcelo Souza, who's the editor of Skies Up magazine, but he's also a professor in Brazil and leads a program of astronomy and astrophysics that is really second to none in the Americas. He's just an iconic person. Following him will be Cesar Brollo, who will give a presentation from Argentina as well, from Buenes Aires. And Franck Marchis, who is the astronomer from SETI, but also one of the founders of the Unistellar company that makes the Unistellar EV telescope. And he also heads up their citizen science program. So Franck will be talking about how people with unistellar telescopes actually did contributions to the DART mission observations. And then finally ending up with Adrian Bradley, who does beautiful skyscape imagery. And so we're going to have a great show for you. Hope you stay tuned in, and it'll be coming up here in a couple of minutes.
Earth is surrounded by asteroids. Most of them are no threat to us, but some are potentially hazardous.
5, 4.
In 2021,
2,
NASA and Johns Hopkins Applied Physics Laboratory launched the Double Asteroid Redirection Test with the goal of smashing a spacecraft into an asteroid to change its orbit.
The purpose of DART is to demonstrate that we can protect the Earth from impacts from natural objects.
Imagine we discover an asteroid that is coming towards Earth.
Even giving it a small nudge, years in advance, will allow it to change its course sufficiently that it misses Earth.
DART would spend 10 months traveling to its final destination, the moonlit asteroid Dimorphos, using autonomous SmartNav technology.
And at about 2.5 minutes out, we cease all maneuvering and we coast until we hit the asteroid.
2 weeks ago, NASA made history once again. And now the team has confirmed that the spacecraft's impact altered Dimorphos' orbit around Didymos by 32 minutes.
For the first time ever, humanity has changed the orbit of a planetary body.
The tail is spectacular, this amount of ejecta that you're seeing, and it's continually evolving. The observations are going on in order to fully track and watch that evolution.
It really is just the beginning of the analysis of this tremendously rich data set.
And it's very exciting to be in this position to be doing this now.
Well, hello everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance, and really excited to have you here on the 114th Global Star Party with us. I see a lot of our regulars are already in live chat, and we have several of our presenters already online ready to go. The theme of the Star Party is a bump in the night, and of course there's lots of different kinds of bumps in the night in space. It's a common feature of planetary formation. It is, what we see, and we were holding up meteorites, comparing meteorites and stuff. Obviously, these were collisions of various types, but humans have created a very important collision with the DART mission, and so I think it's one of the most exciting, probably one of the most important space missions that humans have ever done. And that is to try to solve the problem of a direct hit by an asteroid or maybe a comet. But we've discovered that we can actually move it, and done correctly, we can save a huge amount of life that might otherwise be lost to something like that. So it put a big smile on my face, as I think it did a lot of people. Our first presenter tonight is David Levy. David is with us from Vail, Arizona, and it's great to have him with us, as he always is. David, thank you for coming on to Global Star Party.
Well, thank you, Scotty, and everyone else. It's good to meet my old and new friends here, and I really treasure this event whenever it can take place very, very highly. It's way up at the top of my list. In honor of Tucson tradition, the Tucson Festival of Books, which was just concluded, I was trying to find a Things That Go Bump in the Night poem that would be appropriate. But it turns out that, as educated as most poets are, it's very few of them have actually written books about libraries or books. John Keats, of course, wrote a book about a translation of Homer by George Chapman, one of his most famous sonnets ever. Then felt I like some watcher of the skies when a new planet swims into his ken. But the one that I found is actually a children's poem, which I think is absolutely delightful. It's by Robert Louis Stevenson, and it goes like this. There in the night, where none can spy, all in my hunter's camp I lie, and play at books that I have read, till it is time to go to bed. These are the hills, these are the woods, these are my starry solitudes, and there the river by whose brink the roaring lions come to drink. I see the others far away, as if in firelit camp they lay, and I, like to an Indian scout, around their party prowl about. So when my nurse comes in for me, home I return across the sea and go to bed with backward looks at my dear land of storybooks. Thank you, and back to you,
Wow,
Scott.
that's nice. That's very nice. Thank you very much, David. Um, I see that we were talking earlier about your Acadia shirt, and Acadia is where you got your PhD, is that right?
It's where I got my undergraduate degree.
Oh,
I
okay.
did my undergraduate degree at Acadia,
I
did my
see.
master's at Queen's in Ontario, Canada, and my doctorate I did at the Hebrew University in Israel.
Oh,
So
okay.
3 universities for the 3 different degrees, and I love them all.
But you never stopped learning. I know that about you. You're always exploring and discovering and searching, and so it's refreshing. There are sadly a lot of people that figure they get to a certain age and they kind of cut off the learning part.
Well, one thing, Scott, was that I was actually visiting I was leading a star party
Yeah.
nearby, and I asked the group if any of them had read a particular book. And these were like teenage kids, and not a single hand went up. And then I said, have any of you read anything? And no hands went up. And I said, what are they teaching you in school today?
Yeah.
And I asked again, somebody here must have read something. And one boy did put up his hand and he said, I've read Stephen King's It, which actually is I haven't read it, but I understand it's a pretty good book. And if he has read that, he has read other things as well.
Sure.
So of a group of 25, I found one who had respect for books. And that's a pretty sorry thing.
Well, hopefully more people are inspired to read books or learn in any way that they can,
I hope so. Learning is a lovely thing.
That's right. Well, David, thank you very much. Thank you.
Thank you.
Yeah. Up next, we are going to the president of the Astronomical League, Mr. Carroll Iorg. And Carroll, I'll bring you on with me. You have been with, how many years have you been associated with the Astronomical League?
Probably 25 years. I don't know exactly. I lost count a few years ago.
Yeah. So I remember some of the early times seeing you at the Astronomical League conventions, and you were always involved, always very helpful, always very cheerful, so, and that's your personality today, so, and you have done how many terms as president now?
Well, the original one was 4, and I'm halfway through the second one. I got called back. So yeah, we're on second. And I said I was done the first time, but I think this is for real.
Well, the Astronomical League has thrived under you, and I know that you have huge new membership, especially since the pandemic, and it is, it's no wonder. I mean, the Astronomical League, with all of its awards, all of its observing programs, all of its engagement throughout all the clubs and everything like that, you guys have done an amazing job. And I think that your tentacles are going ever further internationally, and I think that's just so cool.
Well, thank you, Scott. And you've been there with us most of that time as well, from a long time ago, and we really appreciate the support.
Somewhere in the background, just cheering you guys on. That's what I still do. So
that's not in the background. You're right up there helping.
Oh, that's very kind.
And David, it's so nice to hear your poems. I always love what you have to add to the discussion, and I can certainly relate to learning curves. I seem like I'm on a new one every day. And I thought, well, this is the last one I need to worry about for a while, and here comes another one. So, thanks to COVID.
Thank you, and I look forward to seeing you in Louisiana this summer.
Yes, and we're looking forward to having you. And we're going to have a question here in a little bit that relates to that just a little bit. Let's see. I'll share my screen here. Okay, everybody see it?
Yes.
Excellent. Okay, this is the usual warning we have on the first slide. If you win some kind of a prize in this process, to make sure that you don't look at the sun directly. Most of we astronomers know that, but we have to be reminded. It's been a while, a couple of weeks since we had this. So here's the answers from February 7th. I'm going to move this out of the way just a little. Here we go. A full moon shines at magnitude -12. What specific term is used to describe a meteor that reaches at least magnitude -14, i.e. at least 6 times brighter than a full moon? And the answer is bolide. And everybody should got 100% on that. So, all right. And now number 2 from that one. Most meteors become visible in what altitude range? The choices were 5 to 20, 20 to 50, 50 to 80, 80 to 120, 120 to 200 miles. And the answer is C, 50 to 50 to 80 miles. Okay. Then the third one, what famous American singer wrote a hit song inspired in part by his viewing of the Perseid meteor shower during a family camping trip? And the answer is John Denver. I've seen it raining fire in the sky, Rocky Mountain High. So that was a very special song. The correct answers to that one were Andrew Corkle, John Williams, Ezra Mataroso, and Don Nab. And here's the questions for tonight. Number 1, what do we find at the L1 Lagrange point? What do we find at the L1 Lagrange point? And to make sure you send those answers to secretary@astroleague.org. Number 2, Belinda is one of the moons of which planet? Belinda is one of the moons of which planet? And again, send your answers to secretary@astroleague.org. And finally, we finish with this one. Which of the following are speakers scheduled for Alcon 2023 in Baton Rouge? A, David Eicher, B, Fred Espenak, C, David Levy, and D is all the above. And again, send your answers to secretary@astroleague.org. This month, there will not be an AL Live in March, but the next one will be held on April 28th with Michael Bakich speaking about the 2024 total solar eclipse. I can't believe we're getting this close to the annular, but we're almost there for that as well. So it's coming right along. And I think that's all for right now, and I'll give it back to you, Scott.
Okay. Let's see from the audience if my audio is better than it was. There we go. Okay. All right. So, Paul watching on, I think, YouTube, Paul Burgart said that my audio sounded like I was distant or far away or something. So let's see if what I've done is change that. But thanks very much, Carroll. Any further update on what's going on as far as Alcon itself?
Yes, it's coming on very nicely. We hope registration will be available in about 3 weeks, approximately the 25th of March. So we're getting very close, and we'll publicize that fully when it happens. Oh, one thing I did forget earlier, we just crossed another threshold with the league. We are now at 23,000 members just within the last quarter. So we're still striking the chord of people really wanting to get out under the night skies. And Scott, you keep those telescope sales coming so we can continue to get out there.
Well, that's great. Yeah. So, I mean, it's so encouraging to see so many new amateur astronomers in the field. You know, undoubtedly, they are going to, start another wave of discovery and, improving techniques, and even the astrophotography, which we think is so amazing right now. I can hardly imagine what it'll be like another 10 years from now.
There's just so much creativity that's come about from COVID and beyond. People are inventing new ways of handling it all. Our individual clubs are coming up with new ways of sharing the night sky with the public that never even envisioned before this all happened.
Right. Well, very good. Thank you so much, Carroll.
Sure. Thank you.
All right. Okay. So, we have the pleasure of bringing on the editor-in-chief of Astronomy magazine on a somewhat regular basis, which I think is amazing in itself. I really happy to have Mr. David Eicher on our program. It's been great to get to know him better as well, and we learned bits and pieces of the various facets of Eicher. Not only is he an expert in astronomy, but in geology and in history as well. His works on the Civil War are amazing. If you follow him, and you should follow him on Facebook, you'll learn lots of different things that's very interesting about our country, about our world, and of course about our universe. David's magazine, Astronomy magazine, is the world's largest publication on astronomy, and so we're again very, very proud to have him on the 114th Global Star Party.
Thank you so much, Scott, and it's a pleasure to be here as always, of course. And I'm glad that we're having this again. We had a little bit of a break there with a bunch of special things happening. It's nice that we're back and rolling here our way toward spring, which is great.
Yes.
And we still haven't worked our way through hundreds of objects that we'll talk about one by one. No, I hope that's good though, not rather than a threat.
That's good.
But we're still way
billions, trillions of them, right? I mean, come on.
Billions, trillions. We're still way up north near the North Pole, and someday when we're
our catalog yet, so
right.
Okay.
So in our old age, we'll make it to the South Celestial Pole. I think maybe, but unless you boot me out of the cosmos before then.
That won't happen.
But if I can pontificate for one thing, David mentioned reading and readers and young folks. And, this is universal almost, thinking that, well, you want to check something, you go and, you look at the internet. And of course, it's very handy and so on. But if I can be so ashamed to say so, not everything on the internet is reliable, just a word of caution. And anyone who spent a lot of time in a very large library with books, these things that are printed, with pages, there is a very, very small fraction of the literature of the world that is on the internet to begin with. So I know that's a losing argument, but just to mention that if you spend a couple of years wandering through the Library of Congress, the great majority of important stuff for many topics ain't on the internet. So just a word of caution for the future there about learning, which doesn't seem to be recognized by many, many people in the world right now.
Thank you for saying that, David. Really appreciate it.
Thanks, David. But for now, I will step away from that and share my screen. And if I can get the right thing to share, we're going to, and I'll start a slideshow as well, all sorts of things I have to do here. So can you see an illustration of a quasar with jets emanating from the supermassive black hole in the nucleus of the quasar?
Yes.
Well, forget that immediately then, because that's not what we're going to talk about tonight. Okay. Instead, we're going to talk about, we got a really interesting, there's some stuff we've been wandering through that's really obscure. This is a pretty well-known one, even though there are many, many faint planetary nebulae in the sky. The Cat's Eye Nebula, the famous Cat's Eye Nebula in Draco. NGC 6543, it has a very high surface brightness, and it's really good even in a sort of a suburban sky with a smaller telescope. It's a satisfying object to observe. It was discovered by William Herschel in 1786, and it was the first planetary nebula whose spectrum was observed at the dawn of astrophysics in the years of, the Civil War, that whole thing. Not the coming one, but the first Civil War, in our country. Yeah. Are you guys paying attention? There's no laugh for that even? Okay. Okay. Just kidding. But in 1864, as as astrophysics was just beginning, William Huggins, the British spectroscopist, observed this planetary and recorded its spectrum, and he demonstrated that planetary nebulae are gaseous. Of course, it was William Herschel who named planetary nebulae. They gave them their name, and they have nothing to do whatsoever with planets, of course, but they do have disks, of course, in a telescope that look kind of vaguely planetary, if you're, tired, at least. So it's bright. It's an 8th magnitude object. It's small. It's about 20 arc seconds across, but it has a faint outer shell. And of course, as we've talked about before on these programs, sometimes planetary nebulae, sun-like mass stars, as they die, as they expire, will puff off at low velocity gas as the star ends its life. And then, of course, higher velocity gas that creates a shock front and illuminates in a brighter disk the planetary. It's about 3,300 light years away, and that corresponds to a diameter of a little less than half a light year. So it's a little smaller than the size of our solar system, if you will, right now. It's a young planetary. It's still working its way toward expanding. It's only about 1,000 years old. And it shows because of that, it's because of its youth, the faint gas that came off of the star originally hasn't dissipated into the interstellar medium. And so it shows the stages of a planetary pretty well because it's so young. It has a complex inner structure. We can see the mechanism behind that, which is not very well understood even to this day by Bruce Ballack and Adam Franck and everyone else. The structural complexity of this nebula can be seen, however, at high power by visual observers if the seeing is really good. So this is a really good one to go out and look for. And large amateur telescopes reveal hints of a kind of an inner spiral structure of the gas coming off of that bright part, which is very visible, of course, in images made with Hubble. So this is a good one. Here again is a tiny little section of this. It's not the most detailed deep sky atlas that I have around or program online, but it's small enough to be portable. In fact, it's right. I can grab this maybe right here on the edge of things. So this is the Interstellarum Deep Sky Atlas, and you can see it's not super huge, but it has a great amount of detail. So this is an atlas that I use a fair amount, and here you can see the cat's eye is plotted as the, I hope, Scott, you're not going to test me on the pronunciation. I hope the Katzeneggenubbel is the Cat's Eye Nebula.
Is that why it's called the Cat's Eye?
If you're in Berlin, it's the Cat's Eye Nebula. Yeah, yep. So this is German for Cat's Eye Nebula, so to speak. I don't know, German ancestors, but they were over in the United States for a long time. So I don't know, from German. But what's interesting here also, you can see that the north ecliptic pole is practically right on top of the Cat's Eye Nebula, just as a strange coincidence. And there's a little galaxy there too, NGC 6552. So it's kind of a nice, barren area of Draco to look in. And here, this is a very wide field. There you can see the galaxy in the upper left. It's a nice barred spiral. And Don Goldman, who's one of the greats imaging as an amateur, of course, this is a deep shot, and you can see that really large outer halo envelope of nebulosity. And down inside, the very tiny bright spiral there is what you normally see in an observatory photo of the cat's eye. This is really large, this outer envelope of nebulosity. And here we see, you may have seen this many, many times. This is going back. This is the the bright inner spiral envelope of stuff. That's the high velocity material coming off of the elderly star here that is in its late stages. This Hubble image was very famous and made the cat's eye name very famous for quite a number of years back in the starting back in the 90s. And here's
I saw a billboard sign. It just showed an elderly guy on a billboard. It said, "Old is hot." So in this case, of course, the cat's eye. Never mind.
I like that.
Sorry, guys.
And especially because we're all getting to, a little older day by day, but it does beat the alternative. So we'll take it with all of the challenges. And here is a multispectral, a composite of the cat's eye of the very innermost region. And you can see this kind of complex twisting of the gas that is not super well understood. How much of this is physical or velocity driven or magnetic or what have you, But this is a composite from optical Hubble data and Chandra X-ray data as well. That is also a very, very well-known image, of course, here that you've probably seen quite a few times. And I was going to show this a few weeks ago, and I didn't realize the secret intelligence from Scott that we weren't going to have one of these for a while. So this is now a few weeks old, but I just threw in a pretty image of Comet ZTF, which is now on its way out. But we had a really nice comet there for a while, and there's another bright comet for next year that's been discovered. And there's a comet that will be weakly naked eye, supposedly, based on the prediction, by the way, which we can talk more about in the future, that will be visible during the 2024 total eclipse in the eclipse sky as well, which it's a secret, but we'll talk about that in the coming days as well. Which, you're not going to spend a lot of time looking around at planets and, with binoculars for a fifth magnitude comet, probably during the eclipse, but it will be there. So that's kind of a cool thing for the eclipse next year.
Sure.
And just to be shameless here again, this is our 50th anniversary year for the magazine. We're now working on the August issue, which is the 50th anniversary issue, which will be an oversized issue with all kinds of cool stuff in it. And we have an introductory essay from David Walther, who was the brother of the magazine's founder and the publisher, if you will, originally of the magazine. We have a really neat introductory essay from Annie Dreen, the executive producer of Cosmos and the widow of Carl Sagan, about the 70s and what was going on in astronomy and in space exploration with the Vikings and the Voyagers and all that good stuff. At the time, we had that really hot, pressure cooker of astronomical interest then when the magazine was founded, and lots of other surprises too. So that issue is coming up. And again, I will mention that Michael Bakich and I, who have this book out for kids, A Child's Introduction to Space Exploration, we would be mighty proud if you saw that in a bookstore near you.
Awesome.
So, Scott, thank you very much again. That's all I have on the cat's eye and miscellany tonight, and I will stop sharing my screen. And it's good to be back, and we're proud and happy to be seeing the Global Star Party move forward again, Scott.
Yeah, me too. Me too. Very pleased. Thank you so much. Before I let you go, is there? You did talk about the magazine a little bit, but is there anything more special, or nothing could be more special than the 50th anniversary? But anything else that with the current issue that you would call astronomers to pay special attention to?
Well, we're doing a couple of special themes this year that are coming a little later. We did that comet issue in January that David wrote the introductory opening salvo for the whole package that worked very, very nicely. And we have a couple of other surprises coming up later in the year. And we're about to which I'll keep as surprises. But one thing that's coming soon this spring will be a very new and very dynamic and completely novel website for the magazine. And, you know, we have a little shy of 100,000 people now who get the print, and they're old people like me, and so they like that print magazine. But we have about 1.5 million people, unique visitors each year who go to the website. So it's a large audience, and then about 1.6 or so million people who are in the social media network. So it's a large group of people. This new website that we're going to roll out fairly soon here is going to be exciting because it's going to be much, much better than the current website that you can see now. Astronomy.com, of all inventive places, is where you go to see our website. It's not very original, but it works well. So soon there will be a new website coming that will be big, and we're happy to be involved with the League convention in Baton Rouge, as Carroll mentioned. We'll be there and very happy, and David will be as well, and others. So we'll be really excited to be a part of that, as we always have been, to support the League and everything that it's doing as well. So thanks, Carroll, for that.
Appreciate it very much, David. We're looking forward to seeing the gang without giving my quiz totally away.
Oh, no, I don't even know what you're talking about.
I didn't hear you.
But, yeah.
But no, we're looking forward to it, David. Thank you.
Excellent, excellent.
Okay, all right. So we always encourage youth to be involved in amateur astronomy and science education and sharing their knowledge. I don't think you can ever start too young. We're very pleased and happy to have young Navin Senthil Kumar on our program. He's been on several times, and he always gives a great presentation. And so we're going to give the stage to you, Navin. Thanks.
Firstly, thank you everyone. Thank you, Scott, for having me on the show. And firstly, you all might be wondering about my wallpaper. What is it? I'm gonna get that to you in like a couple seconds. Firstly, let me start sharing. So can you all see my screen?
We see your screen. Yeah, you might want to bring it into presentation mode.
All right. So firstly, I have a brand new YouTube channel called Skylight Astronomy. So technically this is my new YouTube channel. I'm gonna share the link like at the end. So yeah. Firstly, please like and subscribe. And I've posted 2 videos about the GSP. So and then now I have an image of Jupiter and its moon. So it's a 72-second exposure by my Unistellar EV scope, and I took it from my backyard. So I'm pretty proud of this picture. So now let's get to this the presentation. 10 crazy facts about astronomy. Hope I blow all of your minds at some point.
You always do.
Okay, so we know that space is like really like big. It's a very vast area, the universe we're still figuring out. So let me blow your minds now. First, fact number 1, space is completely silent. There is no atmosphere in space, which means sound has medium or no way to travel to be heard. This fact number 2, the hottest planet in our solar system is 450 degrees Celsius. So the hottest planet in our solar system is Venus. Did you know that Venus is the closest planet to the sun? Sorry, my bad. It isn't the closest planet to the sun. It's actually Mercury. But then you'd think that Mercury is the hottest, but Mercury actually has no atmosphere, which it can't regulate temperature, which means it results in big fluctuations. Fact number 3, a full NASA spacesuit costs $12 million. That's a lot of money.
Wow.
70% 70% of that cost is literally for the backpack and the control module. However, the NASA spacesuits that NASA uses were built in 1974. If these were priced to today's pricing, they would cost an estimated $150 million.
Wow.
Fact number 4. The sun's mass takes up 99.86% of the solar system. So literally, it accounts for 99.86%. That's a lot of space. So we're barely nothing. And the sun is mostly made of hydrogen, so 3/4 of Earth, with the rest of its mass made of helium. And if the sun ever had a voice, it would be high and squeaky from all that helium. Fact number 5. 1 million Earths can fit inside the sun. The sun is large enough to approximately 1.3 million Earths could fit inside if squashed in, or if the Earth retained their spherical shape, then only 960,000 could fit. But can you visualize that number? Seriously, that's a big number. Okay, it's going to get bigger from now. Fact number 6, there are more trees than stars in the Milky Way. There's about 3 trillion trees on planet Earth and between 100 to 400 billion stars approximately in the galaxy. The sunset on Mars appears blue, since colors are made more dramatic in sunsets on Earth. Sunsets on Mars, according to NASA, would appear bluish to human observers watching from the red planet. Fine dust makes the blue near the sun's part of the sky much more visible, while normal light makes the red planet's familiar rusty dust color in the most perceptible to the human eye. Fact number 8. There are more stars in the universe than grains of sand on the Earth. The universe extends far beyond our galaxy, and the Milky Way, which is why scientists can only estimate how many stars are in space. However, scientists estimate that the universe contains approximately a septillion stars. While no one can actually count every single grain of sand on Earth, the estimated total from researchers at the University of Hawaii is somewhere from 7 quintillion to 500 quadrillion grains. If you want to build a sandcastle with that, that's an awfully big sandcastle. Fact number 9. 1 day on Venus is longer than 1 year. Venus has a slow axis rotation, which takes 243 Earth days to complete its day. The orbit of Venus around the sun is 225 Earth days, making a year in Venus 18 days less than a day on Venus. Guess what? Fact number 10. There's a planet made of diamonds. So the planet's called Super Earth, or aka 55 Cancri E, which is likely covered in graphite and diamonds. So paying a visit to the planet would probably pay for the $12 million spacesuit needed to get there. That's it. Thank you.
Navin, thank you so much. That's great. That's great. So tell us a little bit more about Skylight Astronomy. I just shared your YouTube channel. I found it on YouTube. Search for it. It's easy to find. And but I shared the link so that people could subscribe to it. But how did you get the idea, and what can people find on your YouTube channel?
So far I'm just posting videos of the GSP on there. I'm gonna start getting into my own astrophotography and videos on there. So yeah, I'm excited for that. I'm probably gonna upload some more videos soon.
Awesome. Well, if there's anything we can do to help you build awareness for Skylight Astronomy, feel free to get in touch with me, and we can brainstorm on ideas of getting the word out. So that's great. Thank you so much. Thank you so much. Now we have our next speaker, which is, who is our next speaker? Dr. Daniel Barth is our next speaker. And so Daniel he came to my office. It's fun to have Daniel come because he's always full of energy and ideas, and he was especially excited about this project called the Eratosthenes project.
Eratosthenes.
What's that?
Eratosthenes.
Eratosthenes. Sorry.
It's like the worst.
He probably
It's the
would have
worst.
slapped me. He probably would have slapped me.
It's the worst name to try to say. It really is.
That's right. That's right. So anyhow, but it's a project to measure, to duplicate his test, okay, or his experiment for measuring the circumference of the world, which he, I guess, did so with remarkable accuracy. And that was quite a while ago, wasn't it?
It was about 2,300 years ago, and he came within 2.5% of the modern value.
Wow.
And he was getting the distance between two cities from maps. The Egyptians had been trading up and down the Nile for many, many hundreds, thousands of years when Eratosthenes was there. And so they knew the distance quite precisely, and that allowed him to measure the Earth. And basically, Scott, you get asked the question all the time when somebody says to you, well, what if the Earth's really flat? So we have a model of a flat Earth here. Here's a flat piece of clay. And I've stuck two little plastic bits in there. And essentially, if the flat Earth people are right, when the sun shines down on two vertical sticks on a flat surface, they both would make the exact same solar angle. They would show the sun to be the same height off the horizon. And the length of the shadow compared to the height of the rod would be the same. That ratio between the gnomon and its shadow, or the rod and its shadow, would be the same all over the Earth, because the Earth is flat, right? Yeah. So all these angles are the same. But if the flat Earth people are wrong, what if some of those sneaky astronomer folks are actually correct? What if we now have a curved surface here? And so there's nowhere you can put two sticks and have them exactly pointed in the same direction. They're all pointed directly towards the Earth's center. Our gravitational field defines vertical for us. And so when the sun strikes, we're going to have different angles, different measurements. The trick then, as Eratosthenes knew, is to find the precise distance you are on a north-south line from another observer. Eratosthenes obviously picked two cities which were almost directly north and south from one another, Alexandria and Aswan. That's the modern name, Syene, when Eratosthenes was there. But these two cities were chosen because he knew they were on a north-south line. So it was easy. We've got GPS. Thank goodness we've got GPS. So what we're asking people to do is to measure the solar angle. And how do you do that? Well, Scott, as always, we are fortunate because we are around people who are cleverer than we are. So we have a couple of designs for this. You saw my ungainly one last time with the tripod. This one is something made by a student, and it's just a couple of 90-degree right triangles and some hot glue and a pencil. The line goes diagonally across here. You would use your compass to go ahead and set your gadget up so that the pencil is in the south and the line is pointing north. When the shadow crosses that line, you just mark on the cardboard here, measure height of the pencil, length of the shadow, and record your time of day. You can send it to us. We had another model sent to us by somebody, and they said, oh, well, you know, those plastic triangles you get with drawing sets all the time. And they said, oh, just get two of them and you glue them together so that they form a right triangle. And now you can go ahead and just line the long one up with the north-south line. And when the sunlight, I'm trying to get this here. So when the sunlight falls and makes the shadow, you've got an automatic, again, nice vertical line, everything's straight, clean. And when the shadow lines up, And the reason why we say when the shadow lines up with a north-south line is we want everyone to measure it at local noon. So time zones don't matter. When the sun creates a shadow and it points due north, the sun is crossing the meridian. It's crossing that line that divides the eastern and western hemispheres in the sky. And at that precise moment, the shadow of your pencil or rod or whatever you're using is going to be as short as it ever gets. As the sun rises in the east, as it sets in the west, the shadow is going to be longer. And at this point, when the shadow is pointing due north, it's going to be its shortest length. And all we need then is the length of the shadow and the height of the rod or stick that you're using. And actually, we found in testing that a shorter device, something that's the rod is only the height of a pencil, actually gives a sharper shadow. When you use a meter-long rod, like I was showing last time, by the time that shadow reaches down here on the ground, the tip has gotten rather fuzzy. So it's hard to tell its exact position. A pencil actually gives you a much nicer shadow point. And then it's just the length of the pencil and the length of the shadow give us the solar angle. And with GPS, we can figure out very exactly how far north or south you are from a fellow observer. And so our plan is to go ahead and when people send in their data, we're going to process it all together, but we're going to go ahead and offer people probably through a Dropbox or a Google Drive link, probably both actually. We'll have, here's a data set for you to try with your own home measurement so you can compare yours. The idea is quite simple. If the Earth is flat, everybody will have the same solar angle. We don't believe that hypothesis is true. We believe the Earth is a sphere or a spheroid if we want to get really picky. But essentially, if we measure the solar angle at one position and another, and we know the north-south distance, that gives us an angle. And we can say, that angle is some slice of 360. And so that distance is a similar piece of 360. And so we can go ahead and we can calculate the spherical measurement, the circumference of the Earth. Now, what's interesting, we're going to be grouping these. If we get enough people, we're actually opening it up for an entire week, March 12 through 18. We know it's March. A lot of people are like, I don't get nice weather every day. The nice thing is if you have this prepared and you know approximately when the sun crosses the median where you are, then taking the measurement takes a minute. It's very, very quick, particularly if you have one of these gadgets hooked up right here and it's all set and ready to go. All you have to do is set it on the ground, line it up with a compass, and then when your shadow touches that north line, mark it off, and then measure it later. It's very easy to do. We have in our chat tonight, we have some links. We have one where you can sign up and say, yes, I'll participate. We have another, which is a Dropbox folder. And the Dropbox folder has video links on here's how this works and how we do the activity. It has worksheets both for younger children, say up through 6th grade, and then older folks, adults who have had algebra and stuff. So there's an elementary and basically a high school level worksheet for this if you're interested in that as an educator or just as a science outreach person. What's really nice is tests we've done so far, we've been getting accuracy to less than a 1% error. We've been getting our accuracy down below the 1% level, which we think is fantastic. Ideally, the more measurements we have, friends and neighbors, the more data we get, the better a view of processing this. You also realize this proves the Earth is spherical, not just round in one direction, because we're taking many, many points, hopefully all over the surface of the Earth. If we're getting the same circumference in every spot, then the only possible shape for the Earth is a sphere. So for all the gyrating about that the flat Earth people do, this is a really simple experiment. And hey, if it's really flat instead of curved on top, then you know what? This experiment should show it. This should, if all of us round Earth knuckleheads are wrong, this experiment will slap us down quite quickly. And no, I don't believe in anyone's ability to manipulate a very large data set obtained over international geophysical boundaries around the world. So if we have enough data, we're hoping to group it by day. And if we have enough in any given day, we'll maybe try to group these by their longitude. And basically, if we can group longitude groups and we can group day groups, then we're getting the sky as close as possible to the exact same time and the exact same solar setup with the sun crossing the meridian. That same time, of course, we're referring to local noon, when shadow goes perfectly north-south in direction. So there we go. That's the pitch, folks. I hope that you will all participate, that you'll get these links off our chat, that you'll go take a look at this. I'm doing this with my good friend and partner in crime, David Sederberg, who's a physics professor at Purdue. And he's an Astronomy for Educators fan. He runs a program called Saturday Morning Astrophysics, which, if that doesn't, that's better than your old Scooby-Doo cartoon. So I encourage you to go search him out because he has fun stuff every weekend. And he reached out and he said, I saw this in your book. I want to do it. I'm going to South America with some physicists and some teachers, and I want to do this. And I said, I know a bunch of people who'd love to do this. So I'm hoping we can get everybody in the Global Star Party audience to give this a try. And there's links there for you to send us your data. And all the data we get, big set, small set, we don't know. But we're going to go ahead and publish the entire data set and our spreadsheet for doing the analysis. So we'll share our results. We hope to write a paper on this later. But the first part, the important part, is for all of us. And it's not this week, it's next week. March 12th through 18th will be the day. Look for a sunny day, play, have fun with, cardboard and X-Acto knives and hot glue. Remember what your mom said, put a bunch of papers or a cutting board and don't mar up the dining room table. She won't thank you for that. So,
Daniel, do you need to put marks, centimeter marks or millimeter
no,
marks?
actually, Scott, you do not. All you have to do is you're going to take a ruler and measure off the backside, and you'll measure the length of your gnomon, your stick there, and then there's a little bit of error on every ruler, but it's known.
Sure.
You can put it back there into the corner, and you can go ahead and measure out to where you've got the mark for your shadow. There would be nothing wrong with going ahead and, before you glued this all up, taking a ruler and marking in centimeters. There would be nothing wrong with that. If I was doing it in a classroom, that's probably how I would do it.
Mm-hmm.
But as usual, it's been midterm week here at the university. And so all my teacher friends are all groaning in commiseration with me. So I just finished midterm week with all the projects and the grading and the oh no conferences.
Right.
So I just cobbled these together this afternoon.
So
this one came, David Sederberg sent me. He said, somebody showed me this. I'm like, this is brilliant. And of course, I'm taking that. I'm showing it to all my friends because the cutting out the little right triangles here, I just trace them out with measure them out, and bang, there we go. We've got a nice, perfect, they fit perfectly. And a dab of hot glue, and there you go. Be careful playing with the hot glue gun, kids. But seriously, this is a treat to build. It's very, very simple. It's very straightforward. You just need a square piece of cardboard. You could literally do this out of a pizza box. Cut up the lid of the pizza box, and bang, bang, you could have this together in no time. And like I say, you don't even actually need the pencil. You could just use the tip of the two. If you want to make it very minimalist, just go ahead and use the tip of the two cardboard triangles. because it will make a
Does it
perfectly
have to
nice.
be level when you do?
Yes, it should be level, but again, we're talking something. This is about a little less than this is about 25 centimeters square, so about 11 inches. So you're going to have, if you've got any place that's relatively flat, I mean, you couldn't obviously put it on the hood of your car or anything like that, but any flat pavement or surface, you can set it down on any sidewalk is certainly probably fine. And if we're a degree or two off level here or not perfectly vertical here, it doesn't make that big of a difference. Actually, we measured this. I did the experiments and I measured from 4 or 5 minutes early to 4 or 5 minutes late. So I measured the travel of the shadow, but the sun is at its zenith here when it crosses the meridian, which means it's not changing altitude very fast. It's at the flattest part of its curve going across the sky. So it's traveling practically parallel to the horizon. So over a period of a few minutes, the solar angle changes very little. So this is really, it's a very forgiving experiment. It's a very forgiving experiment, which gives us hope that it will be simple and straightforward enough that everybody can give it a try and send in some measurements. And all we really need, we like to know who you are and where you're at, but what we really need is your GPS, latitude and longitude, and then the height of your gnomon, the length of your shadow, and the time of day when you took your measurements. That's a back check for us because we'll be able to use your location and say, oh, local noon was at this hour precisely. But like I said, within a couple of minutes either way, it doesn't really matter. So I'm hoping that we will get, I know we have many of thousands tune in for Global Star Party each week, and God bless you all for that. And we're so glad for your interest, and we hope you will participate. I'd love to see 1,000 or more people from Global Star Party sending in numbers, because I know we reach around the world to places that I don't personally have contacts there. But Global Star Party does. We reach out.
Star Party does. That's true.
Global Star Party
Well, it'd
swings
be
a big
cool to
bat.
have people in South America.
Oh yes.
You know,
Oh yes. And
Argentina,
I
all of our
have
friends down there, Brazil.
groups of teachers that I talk to in the Philippines and Australia and across Europe and America. And I'm banging this drum on social media as well. So I'm hoping we'll get some teachers to go out and go, ooh, kids, let's send in our data, and then we'll get results back that we can check ourselves, and we'll also get results of how the entire project went.
Great.
So
Great.
I'm thrilled. I'm hoping this will be the first of many. Let's walk in the
I just
footsteps
think
of
it's great.
great
So,
scientists and
no matter
astronomers.
how many people do it this time around, you know, when people get wind of this project, I think it will build more and more.
Well, certainly we could, if this goes great and a bunch of folks say, oh, I missed it. You know what? David Sederberg and I will be happy to do it again. And we can try it in this summer, over the summertime, or maybe next fall when school comes back in session in August or September. And that project and others come out of my works. So if you're interested in teaching astronomy, look up Astronomy for Educators on any search engine, and you'll find the download. That one's for free. This one's to help pay the bills and support all the good work we do. And this is Star Mentor, published by Springer, and more than 50 activities that you can do. Many of them are in this vein. Here's simple stuff you can find around the home. Cardboard, sketching paper, construction paper, glue, and you can do fun astronomy projects and get real data. You can also go ahead with the Star Mentor book, and you can learn how to use your small telescope and binocular to become more proficient. Right. Because the second question everybody asks after, can I see the moon, is what do I do next? And that's what we try to do.
Prove that the world is round.
Yes, we prove the world is round. And you know, one in the eye to the people who say the science is settled. No, I want to do Eratosthenes has rested on his laurels for too many centuries.
He's probably got a big smile on his face right now.
Yes, I think he does. I hope so.
I'm curious, though, about this great mathematician, Eratosthenes, right?
Mm-hmm.
Right? Okay. So
this was at the time when the Greeks ruled Egypt.
What do you think the reaction was in his day of proving that the world was round? Or was it just do you just think it was still kind of like this idea, this theory, you know, maybe some other strange...
There's an awful lot of things that indicate the world's sphericity to us. Among them, the shape of the Earth's shadow on the moon during a lunar eclipse. Magellan pointed that out, that he had more faith in the shape of a shadow on the moon than all the philosophers on Earth. And there are many things that indicate the idea that as we travel longer distances north and south, we start to be able to see different constellations and stars. So there are many things that indicate the world's roundness. And at the time of Eratosthenes, these world sailors and, you know, dominant civilization of their time, they had no doubt the world was round. The question was, how big is it?
Yeah.
We know how much we've reached up into Britain. We've reached down into Northern Africa and the Near East. And this is what we consider to be the world and some of the central part of Europe. But how big is it really? How much of a piece do we have? How big a percent? What's my percentage? As the guy in Brooklyn might say. Yes. So this was of vital interest. How could you do this? This is much the same, the story of longitude, which was made into a lovely book and a brilliant series on television, and tells the story of how do we figure out how far around the world we are. We know about how big it is,
right?
But when we're sailing out of sight of land, how do we really measure how far we've gone? And you can get your latitude, your north-south position quite precisely and quite easily enough. But going ahead and getting your east-west position, for a long time, people were advocating we should publish tables of the positions of the moons of Jupiter, so that if you were far across in the Dutch East Indies and you wanted to know what time it was back in Paris, you could look at Jupiter that night and the position of its moons. And because some of them orbit every 1.6 days or thereabouts, they make a fair to Midland clock. But then people whined about the weather. I have a new telescope and now it's cloudy.
That's normal.
So another method was needed, and they eventually went to timekeeping. And they used the assumption that the Earth is an excellent chronometer, that it is precise and regular, and we can make a clock that we can take on board ship that is precise and regular. And by the distance, the difference from what local noon would be in Paris or London and what local noon is aboard ship or on land at a distant port of call, from that and our reference chronometer, we can see, oh, we're so many hours and minutes off, and so we must be so many miles apart, east-west. And that's the way it was done for some hundreds of years. So anyway, it's lovely to repeat these projects, to go ahead and say, look at this ancient bit of scholarship that we take for granted and say, no, let's not. Let's not take it for granted. Let's get out. Let's explore. Let's do it for us. Let's do it with our kids. For heaven's sake, yes, but just aren't we always striving for, I wish I could see that. I wish I could discover that. Well, now's your chance, folks.
It'll be a moment of personal discovery for yourself.
That's right. Your journey of personal discovery. That's exactly right. So
well,
I hope you'll all participate. And if anyone has questions, the links, which are right at the top of our chat, should help you. And you're welcome to write to me, astronomyforeducators@gmail.com. And I do answer all inquiries that come my way. eventually, although I'm not always midterm time stinks, Scott. It's just, it's the time monster that just gobbles everything.
Right. Well, thanks again, Daniel. Thanks for coming on, and we hope that all of you, build the very inexpensive instrument and participate in this. I think it'll be fun. So I'll do it. All right. Thanks, Daniel.
Thank you, Scott. Good night.
Yeah, good night. Okay, so we are going to take a few minutes. We're just going to take a break. And we're going to learn more about the DART mission. So thanks for tuning in. You are watching the 114th Global Star Party, a bump in the night.
boulders, or if it's very fine-grained like sand, or maybe it's just one big boulder in space. All of those things will cause something different. They'll cause a different crater to form. They'll cause a different ejecta curtain that we can see with Eicher cubed, and so it can teach us a lot about what it's made of after the fact.
The large focus of DART obviously is the impact.
Yes.
I don't know, we're going to crash a spacecraft into an asteroid, but you've mentioned a couple of other things here too. So, I mean, what do you think is the most interesting thing about the DART mission?
I mean, the impact is, I think, so I'm an impact nerd, so the impact is definitely one of my, I think it's going to be really interesting. But my favorite, like I said, my favorite part about any experiment is being wrong. So I think the most interesting thing is going to be when all of my models turn out to be wrong. Like, I'm actually really excited about that, because I think that is when you learn the most.
Yeah.
Right? You think, I know what's going to happen, I know all of these things, and then something totally new happens. To be fair, I think we're going to create a crater, we're going to change the period of demorphos. I think all of that is going to happen.
Good.
I think maybe to get mounts or what we learn about the material properties that we had thought of ahead of time is not going to be true.
Yeah, I mean, right, who would want to think too, like, prove me wrong, right? But that's the essence of science too.
Yeah.
I mean, be able to actually try this, which made me think about what's the most important aspect, what's so important about missions like DART and planetary defense to do these?
So really, I think for me, it's the scale, right? We have this lab, it's awesome. We can do impact experiments, I can simulate them with my models, but those are all really small scale things, right? When we fire projectiles in our gun range, they're like 1/4 of an inch. They're tiny, right? Asteroids are big. They're hundreds of meters, they're kilometers. And so being able to actually get that data point that says, yes, you can go from your experiments in your lab up to reality is really, really important. You can only get that by doing these sort of planetary scale space missions.
Right, some way to get it off the screen,
Yeah.
off paper, out of the lab, and into the real environment to actually see it happen.
Yeah.
Okay, so for an impact nerd, right, and from the
Yeah.
science aspect of this, what's the most interesting thing about DART, about the fact that you're going to have this up-close involvement with an asteroid?
So I think it's going to be what it teaches us about the cratering process on asteroids, because asteroids are kind of weird. What we learned when we took samples at Banu and Ryugu is like the surfaces, they're not what we thought they were. You've got these boulders, you have these spots that are just kind of sandy, they're really, really weak. So if you were to walk on them, you might sink, instead of just, it's really strange. And so I think just understanding how that changes the impact process is really important, because that then teaches us later on, if, heaven forbid, an asteroid were actually coming towards the Earth, it tells us how to better protect ourselves. Plus, it's just cool science.
Yeah, I'm even looking at the pictures behind us here, and these are all different asteroids that we have visited with spacecraft, and look how different each one of them is.
They're all very different.
So even to get this one instance of how one works is incredibly valuable.
Oh, yeah. And as you say, they're all different, and every time we go to a different asteroid, we learn something new. Then this will be another data point. This is going to be one of the smallest ones we've ever visited up close. We're going to have these amazing pictures as DART comes in of the surface, and so that'll be just brand new things that we've never seen before.
We've covered a lot here too, but is there anything I didn't ask, or is it just something you want to add?
Yeah, I mean, I guess to reiterate, it's so important to do these tests at scale, right? We've only done this a couple of times. We've only had a couple of other space missions that purposefully impacted things. We had Deep Impact, we've had L-Cross, and we learned so much from them. And just having these tests at the real scale that teach us the real physics is so important for science, but also for future planetary defense. So DART is so exciting because it's going to give us that data point that we can point to if we need it in the future to extrapolate to other potentially hazardous objects or other asteroids when we're working to protect humanity from space.
And we're all going to be watching that too, as those keep coming in too.
Yes.
So thank you, Angela, and thank you for joining us. Again, I'm Mike Buckley and Angela Stickle. Go DART.
I guess I'm doing everything wrong tonight. I've been having audio problems, and so I've been switching things on and off and stuff, and so sorry about that. But anyways, I do want to apologize for the audio issues that we had, and but we have John Schwartz from LA on with us tonight, and he is already starting to share his screen. So, John, you want to take it over?
Yep. Okay, my screen's not there, but how is everybody doing?
We're all good.
Let me see what happens. Little technical difficult. There we go.
There you are.
Okay. One more second. Little technical right here. All right. So I'm here at Mount Pinos. This is my telescope.
And a beautiful
My
Milky Way
28 inch
behind you.
behind me.
Yeah.
Got a little backwards over here. Anyway, let's share a few pictures that I'm working on. This
Now,
is
let me introduce you to the audience a little bit, John. Now, I've known John for, I don't know, 15, 20 years now. He's an extremely enthusiastic amateur astronomer, loves to do astronomy outreach programs. He was with us at the Starlight Festival in Big Bear, and he did electronically assisted astronomy, really wowing the audience with his massive Newtonian telescope and near live views coming through his instrument of some deep sky objects right from a parking lot in Big Bear. So that was really cool. He is an artist. His family has an art background as well. I think his father actually owns a gallery there in the LA area. And John has worked on movie sets, and he's done all kinds of stuff. So it's great to have him on, and you won't meet a more enthusiastic amateur astronomer. So there you go, John.
okay. Yeah. So we've had a few clouds lately, as you know, Southern California. It's been quite cloudy. I did have the opportunity to do a nice sketch of the Venus-Jupiter transit. It actually just barely cleared in time. So here we go. So now this is actually a digital painting, complete.
Wow.
I use Procreate on my iPad, and I meticulously painted these trees. After a while, it's almost like scribbling. But if you notice, when I zoom in, the Venus, this was through my Leica binoculars, my superb 10 by 50s. I could actually see the moons in a beautiful red spire on Venus, like, because it was in the clouds. So that was a pretty good view for me and a nice sketch.
Very nice.
Okay, I've got a couple more to go to. So this is my latest I'm working on. It's an Orion. This is probably my 10th attempt at this object. It's not quite done yet, but it's coming along. Very proud of this one. So this is a complete digital sketch looking through my 28. Of course, I did the original sketch. It was much less defined overall. But as time goes on, I just upload it to my Procreate on my iPad and I start reworking it. It's funny because I bounce them back and forth on my phone when I see stuff, because I always carry these with me. That's another benefit to digital art. And also, after meticulous hours of averted vision viewing and trying to capture that, it takes quite some time to get these to come together. And this one's unfinished. I'm still working on the star field, but look at the trapezium. how that little ghostly dust cloud is just floating, illuminated by the bright stars centered in the trapezium.
Wow.
So very proud. Okay, moving along. Yeah, it's been a little hot out here too today. You know, I've got a little sun, so it's nice.
Adrian Bradley is watching.
Adrian.
Yeah,
Adrian.
he says that's a beautiful drawing, John. He says
Thank
Scott,
you.
tell him that is killer.
I appreciate it. Why can't I hear it?
I decided to join and tell you personally.
There
That
we
was
go.
beautiful.
Adrian, I missed
drawing.
you. Very nice. Man, I love your work. I really do. It's unbelievable. It's just like some of the stuff I do. So, you know,
Yeah.
when I walk my dog, I see so many great things. Every day when I'm down, I just look at everything outside, and it's just gorgeous. And the sunsets, the clouds, and even the flowers that I send my mom, because I can't bring them, so I send them digitally. This is one I made. This is actually a photograph, but cell phone photo.
Very nice.
Kind of
Yeah,
fun.
I'm not surprised you have a good picture of that flower. Another one. Uh-oh.
Oh,
so I'm still in league, so I may be going on mute.
Okay.
Just to so
What's
you don't
your
have
average?
to be subject to bowling league. But I wanted to come on personally to tell you those
Thank you.
drawing.
Thank
All
you
right,
so
carry
much.
on, John.
Here's I'm going to do one called the Faces of Orion, and I'll show you all the different versions. But here's another mock-up I've been working on. Little different lighting, little different feel.
That looks nice.
Trapezium. You know, the more I paint the dust cloud in front of the actual stars, it gets easier each time, learning how to paint the detail. But so here's another one. I really like this one. This was the first entry of the Mars transit. It was just getting in, and my friend Andrew called me and said, John, you better look now. And I scrambled to get some instruments set up. I made it, but this is my first original sketch, looking through my 16x70 superb Fujinon binoculars. So Mars was coming, you know, up to the moon, and it would actually go completely through the moon and reappear on the other side. But this is just kind of a wide field mock-up I did.
Wow.
Of course,
a drawing of the moon?
It's a disease, man. I get on these things. I worked on this for 2 days. I lose days on these. I mean, it's that involved. Time just goes away when I do these. I got to slow it down. I'm running out of time here. But I mean, yeah, this is a drawing. If I zoom in, it's a little grainy. The resolution, I still have to figure out how I'm going to get these tighter. But it's pretty cool, right? You can see it's a drawing. Copernicus, look at that Copernicus.
Oh yeah, it's very nice.
That, you know, this is cool. I mean, it's tough to get it exact. I need to practice a lot. So, but I did do a few craters too. I'd like to show you. You know, on cloudy nights, there's some amazing crater guys that they are just unbelievable, and they're not even artists. You know, I did a picture of the wife because she's always mad that I never show her. You know, I send her flowers too. This was a cool flower that I sent her that I again saw walking my dog. Look at the beautiful nature. It's just unbelievable how they're all reaching for that light of the sun, the giveth of life. You know, it's just amazing when you see that. So beautiful. And then I promised my wife I'd do a quick sketch. I think she had a different idea, but this was the one I did. I'm a very lucky man. Wife's very nice.
That's awesome.
I had her walking through, you know, her shoe closet because she loves shoes. But anyway, she didn't like it as much as I did. I really did like it because she's very beautiful. I'm very lucky.
Yeah.
Here's a quick Tycho that I did, just a fun, real quick mock-up here. So yeah, right, it's pretty big.
Oh yeah.
Just a very crude, rough, quick rendering. You know, the moon is amazing because, of course, asteroids and debris hit it all the time. So you're constantly, getting bombarded with stuff. Let me show you. This is Gassendi crater. So if you look, there's actually a volcanic cinder cone there right next to Keys crater. It kind of looks like it's bubbled up a little bit.
I like the way you kind of have it vignetted like that, around these features.
Yeah, they do that at the forums. They do all these different style, the way they present the craters, and it's
artistic,
really cool.
But it really draws you into those features, and it's cool.
Yeah, you couldn't imagine being there like a 4th of July celebration, watching those asteroids come in.
Oh yeah.
Check this one out. This is one of my better ones.
Oh wow.
It's called Gassendi crater. I might have cheated a little bit. I did use some LRO images, but I was able to manipulate it to make it look like it was coming from a spacecraft from our point of view on Earth, not as skewed, but
it's okay to mix all that stuff. No problem. As long as you're transparent about it,
yeah, you have to, that's the thing on the forums where you post.
Yeah.
You just have to tell them how it was composed. And, I want to be able to do better renderings, but, I'd have to set the 28-inch up, and that's quite a task here at home.
Sure.
But there's other scopes I could use. I'm going to be putting out a lot of good ones real soon.
Well, great.
So let me see if I can get one more. One of these is my best shot, but I'm not sure which one, but I can at least show it. So this is my actual transit after it went through the other side. So you can see that, how it traversed through the back of the moon.
Yeah.
And then now it's on the other side. It came out the other side. Pretty neat detail here. This one has hundreds of hours to get that, and it started from a very simple skeletal type sketch underneath, very simple and just loose, but nice shapes like a skeleton. And then building layers upon layers over it to, make it look more smooth and natural. I did use a blue filter on this as well as a polarizer because it's so bright when you're trying to look at that detail on Mars. And I used 2 telescopes. I used one of them was a 12.5-inch Zambuto portable, and then the 18 to get to Mars, because I had to use a lot of power.
Sure.
Because the resolving Mars. So, Mars was pretty simple. It was just a quick, sketch of and markings of what I have, taking notes, and then later I come back and rework that. I spend. It's incredible how many. Let me show you one more. That's really cool. This was, I'm still working on it too. It's getting more dimensional. So I'll show it again.
Okay.
My Archimedes.
Oh, wow.
But
again, beautiful.
I mean,
beautiful.
That crater. So in the front of it, where you see all that wispy stuff, those are actually boulders. And when the LRO flew over that, I mean, there are some incredible boulders in there. That you would see that you can't see from here on Earth. But I mean, they're big boulders, like literally football field size, some of them. I don't think that was the actual right one for me to show you. I'm working on another one actually, but anyway, so
Nonetheless, beautiful
that's
nonetheless.
one more for the road. This one was again walking my dog. Whenever I walk him, we always see beautiful stuff, and the sun came out again, so we're happy about that. There it was. It's a beautiful pine tree. You know, our street was lined with these giant, probably 100-foot pine trees. And then over the years, they just cut them out. But these are some of the last 3 that remain on my street. It's one of my dog's favorite. He really loves that tree. But it's a beautiful one.
Well, the universe is absolutely everywhere. And so, you know, there's, I was commenting to my wife, I like to watch, like a lot of us, you know, I like to watch documentaries about astronomy and the universe and cosmology and all of that stuff. And many documentaries about the universe, so, you know, they show, you know, visualizations of black holes and supernova explosions and all kinds of stuff, or racing across space, you know, faster than the speed of light, these kinds of things, which are, I mean, still cool. But a lot of documentaries do not include, you know, the live ecosystem. They don't tie in the live ecosystem of Earth that's here on Earth with how we experience it, and these concepts of the universe. And there's a recent show on Netflix. I don't know how new the program is, but it's with Morgan Freeman, and I think it's called Our Universe. And if you haven't seen it yet, you should watch it, because they tie in, you know, the lives of elephants and penguins and all kinds of stuff in the deepest reaches of space. And it's really cool stuff, you know, so.
Well, this was our trip to Hawaii. I'm still working on this, but that was the volcano. Very cool. It's boiling, I'll tell you, like the sun. Right. But the sun, that thing's really going off right now.
Well, thank you very much, John.
All right, Scott.
Look forward to seeing more of your work next
everyone.
time.
I missed Adrian tonight. Or he's not on yet, or he might not come on.
He's back there. He's back there. He might be able to get away from his bowling tournament. It'll all depend on when the game ends, I think. So.
All right. Well, I wish him luck.
Yep. All right.
Missed him tonight. All right. Thank you, guys. Have a great evening.
Okay.
Bye.
All right. So up next is Marcelo Souza in Brazil. Marcelo is the editor of Skies Up magazine, but he's so much more. He is an incredible educator in at the university, and he makes a special emphasis to get youth involved in astronomy. And so, Marcelo, thanks for coming on to the 114th Global Star Party.
Thank you very much for the invitation, Scott. It's a great pleasure to be here.
Great to
and
see
now
you.
that Brazil now we began the year for us here because the carnival finished in February. Now is the time that begins the year for us. And I will show some activities that we developed here in the spirit. I'm going to share here my screen in a moment. Okay. Here. This is our group of astronomy. Let me see if it's work. Okay. And now I will show some pictures that I took. We are using now make experience with the smartphone to show what we can see with naked eye. And these was the pictures here in a region near us. And this is the big river that crosses our region here. And here was the image of Venus and Jupiter in February 24th. It was great because I had the opportunity to see Venus and the Jupiter for many days here, because we had in January, February, many days with clouds, but in the beginning of March and at the end of February, we had the opportunity to make observations. This again, this now is in February 25. Here again. Here was in March 1st. This is how appeared for us the conjunction that from different places. I saw many different pictures and in different positions, the planets. But here is how we saw here. I think that is almost the same that the Cesar that saw in Argentina, maybe.
Yes, I don't have the pictures because this day in Buenos Aires was a cloudy night, but yes, it's as you told that in different parts of the planets, you have a little difference.
Yes, but in Argentina is like us here.
Yes, it's real.
And in this day, we organize an event in a public square here. We have the participation, most of the participation are kids that bring their parents to look at the telescopes here.
Yeah, it's great.
And on March 4th, we have a big event here. And now in March 4th, you see now that as everybody knows, and saw, now Jupiter is below Venus. Then it was fantastic because we have a few clouds this day, and it was possible to see images like this. I will try to show some image of constellation here. I don't know if they are okay to be shown. Here is, I don't know if it's possible to see. Here is the Orion, and here we have Aldebaran and Mars. We have a triangle here with Betelgeuse, Aldebaran, and the Mars, 3 red stars in the sky. That's something beautiful that we show to everybody in this period. That is fantastic because we are in a place here again, Orion, and here we have the triangle here. That's Betelgeuse, Aldebaran, and the Mars here. They are not red in the picture, but when you see with naked eye, they are reds. And this is the Southern Cross. In the place that you were, here is Southern Cross.
Oh, yeah.
And here, Alpha and Beta from Centaurus here. Here is Southern Cross.
Which is the latitude, Marcelo, in
21,
this place?
21 south.
21?
South.
21. Yes.
21.
21.
21 in Portuguese.
21 in Portuguese.
Yeah. South.
Amazing.
This was not in the beginning of night. This, I think that is 7:30, something like this, because this is how we will see the Southern Cross in the beginning of the fall, the autumn. It is its position. In the beginning of the night, in the beginning of the autumn, on the fall here. We know the seasons by the position of the Southern Cross in the beginning of the night. Then this is position in the beginning of the autumn here, fall. Then in the winter is in the vertical position, and in the beginning of the winter, the spring is in the other side, the same position other side. That's how we know the seasons here. And this is a very special place that we now has a partnership that is a protected region, is a forest near the ocean, It's different from rainforest. It's with very small trees that is near the ocean. I don't know how to say in English, but in Portuguese we call restinga. That is something that is near the ocean. Right? And this protected region, they have 40 kilometers square of area. It's a very big place. And we organize an event there. It's the first event of our partnership. The name is Reserva Caruara. That's a protection region. It's a private protection region. Private protect, I don't know how to say in English, but it's an environment protected region. Something like this in English. That's near the ocean.
Environmentally protected region. Yeah, that's.
Yes. It's a private environment protected region because it belongs to a port here. Here's the name of we call reserva in Portuguese, and the name is Caruara. That is a Brazilian indigenous name. And we don't have lights inside, only in the headquarters that is located in front of the ocean. Yeah. This is the headquarters. You see here, we have a lagoon here, a very large lagoon. They have 14 kilometers of a lagoon. Here is the headquarters, and here is the ocean in front of the headquarters. You see the vegetation here, that is, you have only small trees because you have sands. Right?
Marcelo, one question is,
okay.
In this area of Brazil, is more to the south or more near to Rio de Janeiro?
North of Rio de Janeiro. North of Rio de Janeiro. Yes.
It's amazing because it's different because you have pines near to the ocean. Yes.
But it's not natural from Brazil.
No, yes, I understand. Yes.
It
In Argentina,
from
we have, eucalyptus and pines in our beach. We have only, but are exotic species.
Yes. And here in Brazil, they develop fast than in Australia. We use eucalyptus to make paper here.
Sorry, yes, absolutely. The same in the north of Argentina and the center. Yeah.
And here is the protected region. All of these are protected region. Now we will begin to develop astronomy activities here. We are going inside this region to make observations at night. And I will show how it looks at night. Here, this was the first activity in this red quarter. And we are organizing now walks inside the forest at night to see the sky. Yeah, you have a lot of people there. And you see they have a special lights, artificial lights there to preserve the dark sky. How it looks at night. And here you can see Venus and the Jupiter here up to the building. This was on March 4th, and they have a few lights, and where you walk, the lights only turn on when someone passes there.
Oh, it's kind of a smart lighting where
it's
it
smart
has
lighting.
a sensor to put light.
Beautiful, so beautiful place to make a star party, Marcelo.
Yes.
Yes.
Now you see here, you have
the
lights
sponsor
because
of Sky Apps. Sponsor the magazine and the Saraco telescope, Star Scientific. We need to make a star party.
That would be nice.
You'll be welcome.
Yeah.
Here is the group that was there.
Nice.
This was the first time that was organized astronomy activity there.
Wow.
Excellent.
This is a picture of the moon. Our group, my wife here. Now is something that for me was the most important. This is my youngest daughter, and she, for the first time, was using the telescope to show to the people the moon. She was responsible to put the telescope in the right position and show the moon to everyone. Then for me, this was a unique experience. Now I know that someone here likes astronomy also.
Yes.
She's looking
Marcelo,
there.
how old is she? How old is she?
7 years old.
7. Wow.
Yeah.
Excellent.
Now in February was his anniversary.
Wow.
She here.
Well, she's got a good teacher.
I hope so. I hope so. Then for me, it was fantastic because it was the first time that she was using alone the telescope. And now I have another one to organize the activities here.
No, that's great. Did she enjoy the, showing people the
Yes,
views?
yes. I left her alone with the people, and you see here, we have people here, and she was putting the moon in the right position for people to look at the telescope.
Wonderful.
This for me was most fantastic in this moment.
Yes.
And now we organized the international meet, our international meet here. We already have invited the speaker confirmed. Gabe Gabriel will be here. Janne Roberstad from Norway will be here. She is responsible for the Global Science Opera, and the next Global Science Opera will be about the James Webb Telescope. Beth Maya Foote from International Dark Sky Association. Alejandro Sommer, de Argentina. Do you know him, Cesar?
Yes, I know him.
Yeah, he will be here.
Yeah.
I hope you can visit us too. Alessandro.
One time you come to visit us to Star Party Valle Grande in San Rafael Mendoza, Marcelo.
Oh, thank you.
Yeah.
And I have here one from the north region of Brazil, that Bernerval, that's responsible for a planetarium in the north region of Brazil. And he, in his state, he was responsible to build 3 planetariums. He was the most famous. Here, Julio Flávio, that's a cosmologist near us here. And Eduardo Penteado is a Brazilian that works in the Office of Astronomy for Education for International Astronomical Union. I hope soon we have more confirmations for the event. And the magazine Skies Up. This was the last edition, but soon we will have a new edition. If everyone wants to read, it is available. It's a fantastic edition of the Skies App magazine.
Great.
And what's this, Scott? Thank you very much for the invitation.
Thank you, Marcelo.
It's a great pleasure to participate.
Thank you so much. That's great.
Thank you.
Okay, all right. So it gives me great pleasure to bring on Cesar Brollo. Cesar, you have kindly come on live. We were trying to do a pre-recorded thing, but I think that you got very busy. You know, Cesar's his company, Sirocco Optica, is expanding quite a bit. Okay, and so he was showing me today kind of live views through the showroom down there. And but how many locations will Sirocco have in, let's say, the next year?
Now we have 5.
5. Okay.
5 is a craziness because yes, we changed to 4 to 5, and you know, it's sometimes when you have 2 kids and when they have 3 kids, you know, this was the same because we need to change it. Yeah, yes, or 5. Yes, is it? Yes, I don't have more hands to keep my kids. Well, this is the sensation that we have now because we changed the machines of the laboratory for ophthalmics It's great. It's a craziness because between ophthalmics and my area telescopes and ophthalmic optics too, we are improving a lot of things for this year. Fortunately, we are in a good way. Our government is specialist to make these all things very difficult, but we could fight against the system and have a great project for this year. The new store is one of this. It's a store with a big area of warehouse, like a center of distribution for our e-commerce, on a place where this store in Microcentro in downtown. Let me show you. I think that I have some pictures, and in my presentation I'm start. Let me. I changed the. Sorry, I changed the. You have the you watch the presentation.
It's in presentation mode.
Okay. No, because
the San Juan and the TV.
Yes, thank you.
Okay.
Yes. Perfect. I thought that I show you only the. Well, this is part of the store that you can see. You can see in the screen Kent and you. we are working. Yes, trying the TV system. We are watching who is the best place for the screen to show to the people. You told me today that, of course, that more screen and more special small things to show products and pictures and something that for example we show in the screen is our global star party. Many times I put 4, 3, 5 global star party for the entire day. The people say, you're you. Yes, Marcelo, you, well, a lot, Adrian. Yes, for all people asked me about who is this people, who is that they work. This is you, for example. And it's very nice because it's an optic store, but most of the middle, at 3/4 dedicated to astronomy, the complete warehouse dedicated to astronomy, to equipment, gear, astronomy gears. It will be very interesting for us. Sorry, I returning. Well, I was starting talking about the trip. The trip to San Juan was not for astronomy, if not that was for an idea of my father, 84 years old, that his dream is drive. I don't know the name in English. We call it carrobelismo. It's like like a cart with a sail, with a is to drive with the wind.
Oh, yeah. So it has wheels, right? It has wheels.
Yes, 3 wheels and
wheels and
yes,
a sail, and so
and a sail. Yes,
sailing over the sand dunes or
along
the beach or something.
I never was so
high speed sometimes.
Really high speed. I really was scared because my father said, "Okay, this guy, my father is going to crash." I don't know. No, he really was totally crazy and happy driving 1 hour with a maybe around 25 knots of winds. That is a craziness. And well, I say, okay, if we if you like, go with you and one of my brothers to San Juan. I have friends in San Juan because my, my business is astronomy. And I called to Eric Gonzalez. Eric Gonzalez told me, yes, of course, come with me to the astronomer house in the observatory. And we went, of course, with Eric Gonzalez. That Eric have their time to observation in the observatory in the same time, because I choose, of course, new moon, and we went all together because it's the same area. It's only at no more than 5 kilometers between the mountains and the flat area. Later, I show you a couple of videos of my father driving. This is my father.
This is your father in the back seat?
My father, yes. My father, Dante. My brother, Germán. I have another brother in Italy. Eric Gonzalez, you know him because he's the astronomer.
Yes.
San Juan is it's a place that is amazing. This is La Pampa de Leoncito. This flat area is not water, if not, is the dry lagoon. Very.
Oh yeah, dry lake.
It's dry lake. Sorry, no lagoon, lake. It's a dry lake of 10 kilometers by 4. And this is in the top. Not the top, but it's part of the mountain, of the hill where the house of the astronomer. Here is the facilities for the tool facilities, where all people make parts for the observatory, and now is out of service. The machines are very well functioned, but they don't find people to teach to the young ones to work with these machines. The entire observatory
Vou sair daqui a pouquinho.
The entire observatory, CESCO, is an observatory that was built by American astronomers that came to make this observatory completely. It's amazing. In the 60s. It's an amazing installation. Something that I took the picture of my father with Eric is that my father is starting to explain all about each machine, because he worked with many of these machines. He's a technician, engineer, a mechanical engineer. He worked in the 60s in Portchester, near New York, to have a knowledge element about mechanics. For my father, it was amazing because he felt like in his own house. He talked with a lot of people about the machines, the quality of the machines, Well, later we went to the CESCO telescope, that is an astrograph that I showed you a few weeks ago. It's a telescope. Here is Eric. You have here two different views of the telescope. Beautiful. It's around an F10 two refractors. And it's very interesting because it's a tube that wraps two different telescopes of a half meter each, 54 centimeters. One took measures in the yellow color, and another one take measures of photometry in blue color. The another two telescopes inside the main tube are two 10-inch telescopes, one for LiDAR, laser, and another one for guiding. It's very interesting because it's a telescope that for example, the size of the sensor is like, maybe it's around 5 by 5 inches, the size of the sensor. Now they are repairing and they are collecting funds to buy the new tube with the gas to refrigerate the CCD. They're working with another CCD to take measures, but the main CCD actually is out of service. They are not only the owner of the observatory is the Public University of San Juan. Of course, that in our country, actually, the funds for astronomy, and especially an university of this kind in the province of San Juan, don't have enough funds, enough money to buy quickly this kind of gears. But our idea is helping making a star party, a special star party, top how do you say, special for VIP guests. Programs like you tell me, Pro-Am, it's very good idea for increased foundations, donations to buy this kind of things. They receive visitors, they receive tourists. This is a great fund of money, but they need more things because all time they need not only the money from the prize from the university. If not, they need money for foundations, for anything that they can help, because it's an observatory of complete time where Eric and another astronomers work complete time. It's not for one. It's not for turns. For example, not turns, but if not times for each astronomer. If not, it's a completed time observatory for a special dedication for the university. Here, my father is yes, my father is really curious. I'll say, okay, I can see the lenses. I'll say, okay, sure. And Eric was totally amazed with my father, because my father told him about things about mechanics, mechanics from the 60s, the 70s, the 80s. And that is the kind of people that need to see everything, and was fantastic. Eric show him the lenses. Here you can see the 254 centimeters main for each color, and here you can see the 2 inches, the 10 inches refractors for guiding and LiDAR or another thing that you need. I took some pictures with cell phone. We have many. With Eric, unfortunately we don't have the main CCD, but I put this telescope, this apochromic, in piggyback. Yes, I say okay, and we have fun. We had an apogee CCD to watch some galaxies and make some measures of photometry. That for me, have an eye in a professional telescope it's like a Disneyland, for you too, for any one of us.
Yes.
Here is the area where they receive they receive the visitors. They have two mid telescope of 10 inches that they bought in the 90s. They receive all kind of people. They teach how to take pictures with a cell phone, with a reflex camera. It's a team so kind with the people that is amazing. Here you have Taurus, maybe more here it's Orion. Here, sorry that the pictures that I took was only with the cell phone, because I was so
amazing, Cesar, with the cell
yeah,
phone. Pretty amazing.
yes. The Southern Cross here and the coast in English back coast. I can saco de carbón. Cossack. Yes. Thank you. Ever I forget the name.
Yeah, it's all right.
Yes, it's amazing place for making a star party. Only for 36 invite people. Our idea is make a expensive VIP star party for people that can donate money for change the gas refrigeration system. And it's great. I love that the amateur astronomers say, okay, how I can donate. And this is great because it's something that the people participate in this and don't forget only the money from the university, or it's well, here we visited the biggest reflector in Argentina is this one, is the 2 meters 15 centimeters. It's a telescope that worked from the 80s, was bought in the 60s, but is in functions from the 85. I don't remember, 83 or 1980. Yes, 1985. It's a great telescope. Here you can see technicians working in the filter wheel of the photometer.
Yeah.
I took with these guys and say, hi, how are you? I am teaching too. Yes, we start to talk about the problems and the things about cleaning as well.
Sure.
Yes, we're really, really happy. My father and the observatory.
Wonderful.
This telescope is property of the University of Córdoba, La Plata, and San Juan, that are the 3 astronomy universities in Argentina. Here you can see very, very how do you say, very high end.
Yeah.
Here.
The massive size of that mount.
Sure. Yes. And this is not my mount. It's the mount of the people of the observatory, and they are interested in buy more to teach to the people to make photography.
Very good.
Yes, they have, and they love it. And they tell me, I use it for teach more tricks about how you do use, and and I was very happy to use this. I put I have an IPO of 80 millimeters.
Mm-hmm.
Here is my father. Here you can see the 2 mid 10 inches telescope for the visitors. I took few pictures, only 2, maybe 3. This one is Iota Centauris with a galaxy that is very near in the same line. Here is Eta Carinae. Eta Carinae it's the southern nebula that only Marcelo and me and people from Australia, or New Zealand can enjoy it. Yes, this is a beautiful nebula. Only I make this only with a EXOS 100, small. I have the same. Adrian Brollo and me, we have the same gear, the same small 80 millimeter telescope. The problem is that I have one of these, it's another brand, but because I sold all 80 millimeter of Explore Scientific. Next time, keep one for me, because the problem is that yes. No.
That's a beautiful shot. Thank you, Cesar. Thank you.
Yes, no, it's a pleasure. And this is the last of my presentation, the occultation of Jupiter. This is near to the occultation, and this is the apparition of Jupiter, very low in the and here is an video where we make the transmission for the public TV, because I know to these people they started going to Observatorio San Miguel, and they came to my rooftop in my home, and was great. Yes, because Agustin, my son, prepared an excellent transmission of image for them, for the people watching this. Let me show you here.
Yeah, that's a great way to do astronomy outreach, isn't it?
Yes. This is the same that all people in TV watch from my rooftop.
Awesome.
It was a revolution. Yes. It was a revolution because was something that sometimes is magic that for us is something maybe sometimes normal, but for the common of the people, they ask how is possible, and but it's really magic. It's amazing.
Wonderful.
Yes, and well, here of course a little more, and the apparition here. Maxi took a beautiful picture of this, but for many people was impossible to watch because was really low in the horizon.
Yes.
Here, because in the rooftop of this building is 126 meters.
Sure. Well, thank you so much. I know it's late there, Cesar, and I know that you're exhausted because you've been working all day.
But it's a pleasure. Really, thank you very much. Thank you very much to you, Scott, that to give me the opportunity to show this. And of course, next time I'll prepare much further a video.
We'll be on next Tuesday, okay? So
yes.
115th Global Star Party next Tuesday on March 14th. So
absolutely.
All right.
Yes.
Cesar, thank you very much. Okay.
Good night. Bye-bye.
All right. So up next we have Dr. Franck Marchis. He is one of the founders of Unistellar. He's also an astronomer at SETI, the Search for Extraterrestrial Intelligence. And he is live with us now from California. It's great to have you on, Franck. Thank you. You've been busy with the Citizen Science Project with Unistellar. And I saw briefly an email, some excitement about the DART mission And what can you tell us about what's been going on?
Yeah, thank you, Scott. Yeah, it's been a very busy time for us at Unistellar and SETI Institute because we published last week a paper in Nature describing the result of the analysis of observation collected by the Unistellar network of the dark impact before and after as well. So I have a few slides that Ariel Gekowski, who works in my group, prepare, and I want to describe a bit more with some visuals what we did.
Great.
So in short, the dark impact happened in September 26, if I remember, at 2 a.m. In Europe. And this impact was visible from the southern tip of Africa, South Africa, Namibia, Réunion Islands, Seychelles, Madagascar. And so what we did, we mobilized our network of unistellar telescopes. I remind you that those are small telescopes. I normally have one behind me, but today, for some reasons, I don't have it. But you have one on the screen. Those are digital smart telescopes that are relatively easy to use and powerful. They work in cities, they work in the countryside. And so we mobilized our network, and we told our network about this event and ask some of our users to observe it live during the impact as well. So some of you may have seen the live show we did at SETI Institute for like 2.5 hours, where I invited scientists to work on the project, including the PI of the DART mission, Andy Cheng, who talk about the event and what they were expecting, and then we followed the impact as it was happening. And at the same time, from Réunion Island, close to Africa, one of our users, Patrice Suet, show live the event, and we saw the impact. And I'm going to show you that and going to tell you a bit more about what we derived. So this is the Unistellar network that contributed to the observation of the NASA dark impact. So we have, in this paper, we have 9 professional scientists who participated to the analysis, mostly the one at Unistellar and the SETI Institute, plus some additional scientists from elsewhere. We have 31 citizen astronomers around the world from our network. So you can see we have contribution from every continent, in the US, in Europe, in, I mentioned, Africa, Asia, Australia, New Zealand. So we combine those observations together to understand really what we were observing. Let me just go full screen here. All right, so Suzanne Murabana and the team of the Traveling Telescope organized an outreach event during the impact. And this is some picture that they sent us shortly after. And they observed it live from Kenya with our telescope, with people around, and really to connect, to appreciate the importance of observing an event which is extremely rare. I mean, this is the first time humanity tried to divert an asteroid body. We have not done that yet. So that was very an interesting event to witness. And they managed to do it together with 3 other team. And this is a video of the observation collected by Bruno Payet from Réunion Island. So you can see Didymos on the right moving. And you see
wow.
It's the puff of the explosion.
Wow. God,
So
Frank,
that's,
that is extraordinary. Really.
yeah, that's really,
Congratulations. That's extraordinary.
frankly, I mean, people know me. I was speechless when we saw that. We saw
Yeah,
that
I'm
live,
sure.
and I was not expecting something that impressive. I knew something would
But
happen.
look at that, the diffuse
Yeah.
material blowing off there, and
The ejecta and the material going up. So
sure.
this tiny dot is not Dimorphos only. Is Didymos the primary, which is 400 kilometer diameter, and Dimorphos the moon, which is 100 meters. Sorry, I say that's meter, 400 meter, 400 meter. So this is a relatively small body impacted by a a mission which has a relative velocity of 22,000 kilometers per hour. So we really try, this is an impact of a small body with another large asteroid, and you see the impact, you see already how impressive it was just by watching it. So we put together the observation. This is some snapshot of the observation, and you clearly see a change of brightness between the observation before and after the impact. Before the impact is 2311 UTC, and after the impact is the time that I cannot read because I have my window on it, but you can read on the top, on the middle. This is at the time of the impact, and then you see the ejecta here.
That's just incredible.
And how it basically spread around. But that's not all. In fact, we monitor later on over the 26 days after the impact, the evolution of the Didymos, and we saw the brightening reduce slowly, and we also saw the creation of a tail, a new tail, a tail appear. Very
faint. The tail is like 10,000 kilometers long, something
yes,
like that.
10,000 kilometer length. And this is a tail which is almost, it's located in the opposite direction to the sun. So that's implied that those grains here of material are extremely small because they push by the solar wind, basically. That's the sun interaction that push these tiny grains of material produced by the ejecta. So those that
I am really amazed, and so is our audience. You can see there's comments here in chat. I think everybody is blown away.
Yeah, and this is coming from observation with this 12 centimeter, 4.5 inch aperture telescope. I mean, the technology evolved so much that we are now able to see things like this with the detector we have and this technology. So that was very impressive. The impact was impressive. The aftermath of the impact was also impressive. And frankly, it took a lot of us by surprise. But
yes,
luckily, I just hired Ariel Grekowski, who is a cometary activity scientist. She has studied comets over the past 5 years with Dave Jewitt at UCLA, and she joined our group as a cometary specialist. So she basically quickly understood that what we have done here is to create a comet.
Right.
Right? So she could use all the knowledge she had about comets to derive meaningful information about this impact. I'm not going to give you all the details because it's a scientific paper in Nature, but I'm going to show you this. This is very cool because those are 3 observations from Réunion Island, close to Madagascar. We have multiple users over there. Réunion Island is an island which is part of France, the same way that Hawaii is part of the US. And that's where I'm from, by the way. So that's one of the reasons I'm really happy to see this scientific result coming from the country of my mother, which is kind of a personal success for me. This is something I really wanted to do. So you can see the increase in magnitude is 2.5 magnitude increase, factor of 8-9 roughly in brightness shortly after the impact, and you can see the decrease as well over time. So this is the same diagram, but in this case, we observe for 27 days. So you see the contribution of people around the world, from the Seychelles, from the US, from Australia, Japan, Asia, etc. And you can see the slow decrease, linear decrease in magnitude of Dimorphos. So what happened here is that after the impact, we have probably a cocoon of material around Dimorphos, and then slowly these materials went back onto the asteroid or got ejected by the interaction with the solar wind. So slowly it cleared out, basically, and that's what you see. But it took 27 days for the asteroid to lose this cocoon of fragments around it.
Wow.
So combining...
This is so cool, Franck. I am it's startling to realize that, you can take a telescope as easy to use as the Unistellar is, but you are doing high level science with it. And those images are, my jaw just dropped when you showed those. I have not seen those images before. Frank and I occasionally email each other, but I had not looked at this data before. And so I am blown away. I really am.
Good. I'm glad to hear that you're blown away. I was as well, I will say. We made bets. That's also live in the show the Institute about what will happen. And I was the most optimistic. I said we're gonna have an increase of factor of 2 in magnitude. Yeah. Right? Well, even my optimism got lower than what we were expecting. It's been an interesting time for us to get this data and to analyze them and to put together a coherent analysis as well. Because from those diagrams and so on, we basically confirmed the amount of energy that was transferred from the impact to the moon. And we have the same order in energy that what was calculated by the other team that published paper in the same nature, at the same time. So we have the same result, in fact, using our small telescope that people got with the Likia or the Hubble Space Telescope or the continuous observation of the transit. We derived that the efficiency of the deflection was higher than was expected. So what is important here is that we believe now that we have validated the kinetic impactor as a way to deflect an asteroid. So if some threat comes to us in the future, we know we can use this technology to deflect the asteroid. And this has been done using data coming from citizen astronomers.
To me, Frank, this is as important of, I think, any space mission that humanity's ever done. I'm not saying that as a kind of tongue-in-cheek kind of thing. This is something that quite possibly would save humanity and anything else above the ground. Okay.
Yeah.
In case of a large asteroid strike, and so while there's no guarantees, there was absolutely nothing in place. I mentioned it earlier in this show. Some of us might remember when the International Astronomical Union said that the minor planet Apophis would indeed strike the Earth at one point. I think landing somewhere off the coast, I don't know how many miles off the coast of California. And they described the impact and how catastrophic it would be. And they said it's going to happen. And at that time, there was nothing in place, nothing we could do, okay, to prevent a strike. And so to see this happen is one of the great things of humanity to accomplish.
Yeah, planetary defense is truly it's an application of the astronomy to solve a problem that could have a huge consequences on the future of our civilization.
Yes.
So it's not only astronomy, there is more than that. It's beyond, it's basically a survival of a species, which is being tested by this kind of experiment. So I like the fact that we validated the kinetic impactor for multiple reasons. I mean, we have this idea of sending nuclear nukes to explode the asteroid and so on, but we have so many complications because just putting nuclear bombs into a rocket, it's already a problem, politically speaking. So here we have validated a technology to mitigate, to deflect an asteroid that will not need this complicated, politically speaking, technology. This is easier to do in a way. We will be able to launch a spacecraft to deflect an asteroid if we know well in advance if this impact will happen. So we also have some weird things. I'm not going to go through all of it because we have some interesting observations. Like we have seen a reddening. And we saw that live too. In fact, with the Unistellar network, you can see colors, as you probably know, because we have a detector, which is a color sensitive detector. So during the live, suddenly we saw this color changed after the impact. The asteroid became redder. We don't know why this is coming from. If it's coming from the dust itself, some kind of geometry, or if we have excavated the interior of the asteroid and reveal the true color of the asteroid, which is redder than the surface. So that's what this diagram shows. Basically, and the line is the time of the impact, and the curve showed the difference of color B minus G, blue and green, or blue and red. So I'm not going through the detail of that because we don't have an explanation yet, but that's an interesting thing which we need to understand. Right now, we don't have yet an explanation. And I would like to mention that we are the only group who published the result of the impact live. Hubble Space Telescope missed it. JWST missed it. We succeeded in observing it.
That's awesome.
And the reason is because we have a network of people, citizen astronomers, motivated enough to stay until 3, 4 a.m. to do these observations.
Sure.
There will be always, I always said there will be always a starry night in the Unistellar network. There will be always someone observing is something happening in the sky. And that's a clear validation of the fact that we have telescopes everywhere now.
And this is something sorely needed by the professional community as well, right?
Yeah. It's that's the reason SETI Institute partnered with Unistellar. We knew that this network has a huge potential to be able to observe any part of the sky at any time. So I want to mention some of the people who contributed to this because, as I mentioned, those citizen astronomers, they stay awake until 3, 4 a.m. to observe. They send us the data. They help us as well doing the analysis because we often need some information from them. So Patrice Huet from Réunion Island, this is what he mentioned, the feeling he had after he observed this emotional moment for him. And this is Réunion Island. In the background, you see the Piton de la Fournaise, which is an active volcano over there. So we have also Patrick Huth. He's a community college instructor. He's one of we have a program at SETI Institute where we deliver a unistellar telescope to community colleges, and we train the teachers, the instructor, to use them with their students. So Patrick Huth is one of them, and he has been using his telescope with his students, and he observed the dimorphos and the after the dark impact in his classroom. And this is Ian Svensson from New Zealand, who also contributed significantly to these observations. Darren Rivett from Australia, who has observed as well from his I forgot the name of the city, but in his southern Queensland in Australia. So yeah, we have this network of people motivated to observe the dark sky and to do observations, to enjoy observing those galaxies and nebulae and comets, but also to do meaningful science. And now I want to emphasize that we are not only using the data of people at the Unistellar network, we are involving them into the data analysis and their co-author as well. So those researchers, those citizen astronomers are co-author of the Nature paper, and some of them are extremely proud to be part of such an amazing scientific adventure.
Absolutely, absolutely.
And that's all I wanted to say. I could talk forever about that. But,
Frank, I do want to say something here. There are, I know that there have been advanced amateur astronomers that did not give enough credibility. And I'm guilty of this myself to the Unistellar telescope. Okay, I'm going, it's only 4.5 inches and it's this and it's that. However, I will tell you that seeing this data, okay, and knowing that this is something that that you could do on occultations, on comet outbursts, on this amazing DART mission. Okay, it's historic, and it is. It puts this telescope, I think, as a forefront tool to people who actually really want to do science, because scientists need the equipment to almost be invisible. They need to concentrate on the moment. Okay, they need to be there, and the Unistellar lets them do this. Okay, and so that is incredibly important. And many people, they own many, maybe tens of thousands of dollars worth of gear, but rarely do they do science with such an instrument. This thing allows you to throw it in a backpack, go to anywhere at a moment's notice, okay, and get data, and that is very important. And being able to join a global science team, led by Franck and the people at SETI, I think is just nothing short of breathtaking and amazing. It's brilliant, and I'm definitely one of the converted.
Thank you, Scott. Wow.
That's
Well,
the truth.
I hope we're recording
I'm
this.
not trying to sell it here, but I will tell you, I'm just dumbstruck by the results. It's just incredible. So, well, thank you. Thanks for coming on too. I know that you've been extremely busy, and you didn't have much notice for tonight, but it's really amazing. And so, anyways, I'll let you go. But
thank you very much. Thank you,
thanks
everybody.
again. Thanks again.
Bye.
All right.
Thank
So,
you.
okay. So up next is someone who just finished a night of heavy duty bowling, right?
Yep. Astronomers should stay busy. Exercise. This is part of my exercise, is bowling. Unfortunately, it means giving up a beautiful night. The late full moon is up now. The worm moon, very bright in the sky still, probably about 98%. Scott, is it about 98%
Yeah, I think
full?
it was full. Wasn't it full last night?
Yeah, it was full last
Yeah,
night,
it was
and
lighting up
a
the
few
parking lot
people.
here, that's for sure.
Yeah, it warmed my heart. Actually, what I'll do is I'll see if I can find a picture.
Okay.
My daughter took a picture of the moon and shared it with me. Let me see if I can. I'll share this one. Let me save this to my. Oops. Oh, here we go. Save photo. Showing photos. Okay, let me. I'll go ahead and do a quick presentation. I think we won points. I think I won 2 out of 3 of my matches. But we're here for astronomy, so I want to share photos, and I am going to, I guess I can add a few of these. I'll add 4 photos that I'll share from since the last time we did a global star party. So hopefully, Scott, you're seeing the picture my daughter took.
Yep.
On her way to school. She probably with her cell phone, and she captured the moon. I don't know if
all
this
these wonderful cell phone. Yeah, I keep hearing this. I'm sorry that this image is only taken with a cell phone, and I'm looking at amazing cell phone astrophotography.
It's really coming. The cell phones are getting a dynamic range that's allowing it to capture. When you zoom in, you see some detail on the moon. Is it the best?
Look at that.
Well, but it's really good. Now, this is with my camera before the moon got full. I actually did a video. I have an SV Bony 102 ED refractor, and I mounted it on an IXOS 100 from Explore Scientific. So it was nice to use it. And so, but before I went ahead and took a handheld photo of the moon. And I don't know if zooming in, if you're
yeah.
able to see. Yeah. So this is what I was able to do with a camera. And then when I hooked it up to the telescope, this is what I did with the telescope. So a little bit more detail, a little different, a little bit different exposure.
Senthil, watching on YouTube, wants to know what cell phone was used. Do you know
The
what model?
I don't. Well, I do believe my daughter has an iPhone.
Okay.
Yeah.
Probably one of the newer
So
ones.
this is definitely not a. This was both of these. The camera.
Yeah.
Yeah. This was a Sony A7R4 mirrorless camera connected to. This was connected to a 600 millimeter camera lens. This is connected to the 102 ED refractor. And this was my contribution to the conjunction that happened over the past few days of Jupiter and Venus, Venus being the brighter of the two. So these were the four things. I basically did get out and take some pictures. Let's see, where's my stop share? And you can hear there's some of the noise in the background, so I won't be able to present too long. Everyone's just getting done with their bowling. But yeah, so I was able to get a couple of pictures, and I did enjoy getting those. So the plan is to now I have to wait out the moon, and once we go darken the moon again, I'll try and get back out and get some images. For those who consider Milky Way season the time when the core rises, that time is now. Early in the morning, 3, 4, 5 in the morning. And I think that includes daylight savings time coming up. So if you get out there 3 in the morning, 4 in the morning, before sunrise, a couple hours before sunrise, you will see the core of the Milky Way rise. And I'll see if I can share one more set of images I have. Here they go. I should be able to do this. Let me share. Let's see. It wants me to pick something, so I'll pick the screen and start the broadcast. Let's see what happens. Okay, so now it is sharing screen. So here is an image I took. When you do moon images, and you have stars with them, the actual size. Yep, there's a halo around the moon. I was able to capture it. It was almost
like
straight
a double
overhead.
halo.
Yeah, and then you see Taurus over here. Actually, so this was done with 2 images, one to expose for the moon, one to expose for the entire area, including the halos. And the actual size of the moon in photos like this, when you do a wider angle, it can kind of stun you. That is a true to life size of the moon against the rest of the night sky. It looks bigger, and a lot of times in composites, it's made to be bigger, but it really isn't. It's a small, tiny little thing. Let's see. This is the picture I like. One of the pictures that I like. I may have shown this at the last Global Star Party. Yeah, this was 3 weeks ago. I believe I shared this one. That was my farewell to the comet.
Yeah.
And the little spot right in the middle was my farewell. There's a comet right there. Some folks are still getting pictures of E3. It hasn't left us yet. Mm-hmm. So, yeah. So I do have a full moon. I think this is the state the moon is in now, if I'm not mistaken. It's in this state. This is a waning gibbous, just like the moon is now, which I like to call the late full moon because it rises late, after sunset.
I have a question for you, Adrian.
Yes.
When you see the full moon like that, do you and the dark Maria and all the rest of it, do you see a man in the moon? Do you see a woman in the moon? Or do you see a rabbit?
I generally just see the Mare. It's boring.
You
I
just see
become
the
bored.
Mare.
I just see Copernicus. I see
Yeah.
Aristarchus. And if I, do the saturation trick, then that goes blue. I do, when I see the moon upside down, as in let me see, I might be able to do a quick little, I can't do an edit here, but if you flip this upside down, I do see the bunny rabbit in the
There
moon.
we go.
Yeah, I see the bunny rabbit in the moon whenever
I can't
it's
unsee
upside
the
down.
bunny rabbit, so.
Yeah.
But
Yeah, if you
somebody
flip it
showed me
around.
that there's the cartoon of Wilma, in there. Now I'm looking at it, it's like somebody wearing sunglasses. I don't know.
Yeah.
The mind makes you, put things into shapes, so.
Yeah. This area here, these areas here often become puffballs for whatever shape that you want to see. This is a fuller moon from, I think, last month. This was the 99.8% full moon taken with a camera. And yeah, the Mare that we get to see, you may think the other side of the moon would be intriguing, but in fact, I'm thinking, it may be boring because there's very little Mare on that side. There's just the one little Mare and the big crater. If we did see the other side of the moon all the time, we may not, it may be less exciting. I mean, it would be more of a huge discovery once we were able to go around and take pictures from the other side. If things were flipped, of course, we know physics generally doesn't allow for that, but if this were the far side of the moon, we would be amazed once we finally got to see it. I actually think that the near side of the moon is it's a great side to look at. So, as a reminder, this part of the Milky Way, I consider Milky Way season any season at all.
Yeah, every season
is Milky Way season. Somewhere in here, I have this is what it's going to look like. So all you Milky Way shooters out there, it's going to rise just like this around between 3 to 4 in the morning. I think that was around the time I took this shot. I came out and I got those photos. Somewhere around here, though, I think I have a picture of all of the okay, here we go. I have a picture of all sides of the Milky Way, and I think I did a presentation on it. This region, which brings Andromeda and M33, that little speck right there, and that's a NGC object. That's the section that everyone loves, and when a plane interrupts it, you just have to take another picture. It's the brightest region in the northern hemisphere. That's the next brightest region, the Cygnus region, and a lot of sky glow. And then this region is under imaged, Scott. It's the Orion region. It's a beautiful region full of dust lanes. All of these nebulae that are here, they're the subject of individual shots, but there's just so much here. Yeah, there's so much here. That's the Rosette. We know the Rosette Nebula wins a lot of titles in deep space, deep sky object astrophotography. But here you can see, compared to the rest of this whole area, it's just a speck. I mean, this area is massive. California Nebula up here, the Pleiades, and a little bitty void that kind of goes around. There's a little dark region, but when people image, they'll see the dark region, the gases and everything, or the dusty regions, and they'll be like, that's interesting. Well, these are dust lanes of the Milky Way going in between it. So it's often interesting that, when you you shoot all 4 regions of the Milky Way that we can see. Now, the other 2 regions we can't see below Orion, and I think if I shoot this, okay. So here we've got with the zodiacal light. There's Orion. Below Orion, all the way, if you go kind of equal above the horizon, if you go that distance equally below.
Giant comet. It's awesome.
Yeah, it does. The Magellanic clouds are below horizon. If we could see through the horizon, we would see the large and the small Magellanic cloud. And I believe they would be on the same side as Orion in this picture. With the galactic core, if we could see below equal sides of the horizon, we of course would see we would see I think Alpha and Beta Centauri, we would see Crux, the Coalsack, we would see Eta Carinae, and that whole rich region of the Milky Way that shows up in the south. That is all below horizon here. And then that leads into the other region where Canopus and the large Magellanic cloud, the small Magellanic cloud, and then it circles back to Orion. And so those are the 2 regions of the Milky Way I need to get in order to complete the Milky Way circle. A couple of photographers were able to do it. It's pretty amazing. They image the entire Milky Way as visible from Earth. And it's a big circle that goes through the 4 regions you see here, and then the 2 from the southern hemisphere. I call them the 2 regions. But the part that we can't see here in the northern hemisphere. So that's a goal. I do have a passport, so I will try and get those other 2 regions.
You got to use it. That's right.
I got to use that
Get some
passport.
stamps in
Absolutely. Yeah. So I'll stop my screen broadcasting here and go back. So yeah, I've been busy with some other hobbies. We had some rough weather. We're finally getting some clearing, of course, when the moon is out. And but anytime you can get out here and enjoy the night sky, it's go out there and enjoy it. And then if you can get some exercise, go get some exercise, indulge in some of that. But don't forget to get back out there in the night sky, because it is a great stress reliever when you can go out there. And it relieves more stress for me than bowling does, although I'm getting back into it. So, yep, be well-rounded, enjoy nature and each other.
And have fun, so that's the whole name of the game, is to enjoy yourself.
Yeah.
And love what you do, just seize the day, man. So
yep, and do some science. Now, I found it interesting that and you can give me your take on this, Scott, we didn't have a lot of media coverage when Jupiter and Venus drew close together in the night sky. So, behold the internet. I saw a lot of talk of aliens and UFOs because you had 2 bright objects near each other.
Yeah,
and
there's always a lot of conversation about this. I mean, certainly, one of the, I think, really compelling things is that we know life here on Earth is pervasive. I mean, I've even had, I think it was Seth Shostak, who actually has some scientific data that if all the atomic bombs, that the entire supply, the entire arsenal
went off,
was let go, okay, and that humans would still, it wouldn't wipe out all humanity, and it wouldn't wipe out all life on Earth, okay? It would be nasty and it would be horrible, okay? But life is so pervasive here, okay? So if it's pervasive here, okay, then out of the trillions of planets that probably just inhabit our own galaxy, and then I don't know how many galaxies there are, but take that number and just keep multiplying it.
Yeah.
There's gotta be another place out there where there's some flora and fauna, and so I don't personally. I'm still very skeptical about UFO, UAP from alien sources invading Earth. I mean, and I will be until I shake hands with a space alien, and there's 3 other people around me doing it at the same time. Okay, it's not just me doing it. Okay, so and that's just me. Okay, but do I believe that there's life elsewhere in the universe? Yes, I do, and I think most people believe that. I have heard that the number of people that are believers in that we have been visited by alien beings, okay, and I'm talking about from other planets, other stars, galaxies, whatever, is somewhere in the 60% or 70% range, something like that. And so, and I have friends that have had experiences and this kind of thing. I just personally be one of the guys that is skeptical. Okay, so I'm not going to call people liars. I'm not going to do that because the minute
well,
I
they
do,
have great
so
imagination.
prove me wrong. Okay, so,
well, we can say that they have a vibrant and active imagination, and 2,
I don't know, so I can just tell you that's kind of my own personal. You asked me what is my personal take. That's my personal take.
I think it's a good personal take, and of course, we can only come up with things based on our own experiences.
That's right.
And what that tells me is that the average person, maybe there's something about the movies that we've seen that explore some of these things that are ringing a little too true in the minds of the moviegoer. It's
one of the things that that I think that you might think about is there are some cosmologists that they I think that some cosmologists believe that if it can be imagined that somewhere out there it's happening. Okay. Now,
the Star Wars,
black holes, for
Star
example,
Wars and
where
Star Trek
the
theory.
monsters of the universe, just pure science fiction to us, and now we've got an image or 2 of black holes. We've got compelling evidence that there's black holes. The Navy release of what they're calling UAPs. I mean the Navy. The military is saying that okay, these are things that we can't explain, but
we're working on it.
We're working on it.
But we're working on it.
And
we're sending
personally,
F-18s to investigate.
If it came to be true, I would be personally very excited about that. But there's still that skepticism I have. I don't know if you'd call it healthy skepticism or not, but I am skeptical about these things, and I just need more evidence to support it. So that's all.
Yeah, I agree. Well, being science-minded, I think we tend to want to see the evidence a little more. The movies may be plausible, but we're more likely to question things a little more. I think the average person, like you said, that 60% or so sees it, and that's all that's needed.
Of people.
Yeah, and that's the majority
and
of people.
This also includes my parents, okay? Both of my parents have claimed to have seen UFOs, okay? And when I went on television as a UFO skeptic,
told me he saw
they were
one.
very disappointed in me.
Yeah. Oh, well,
they were very disappointed.
I have a brother-in-law that to this day swore that he saw when we were coming out of a restaurant, and he said, "Did you see that? Something with wings that was silent." And I was scanning the winter circle to see how much of it I could see in that area. And he said, "Did you see it? There was there was some weird craft there." And I didn't doubt him one bit. I didn't see it, and I didn't look at it to see, was it, because sometimes planes can zoom in and out of clouds. And so it gives a weird look because all of a sudden the plane appears and all of a sudden it disappears, and then the light, sort of is the last thing to go. But, it's nothing I worry too much about. But it looks like they're about to close down the bowling alley. So I was glad I could make it. I'm glad you stretched out Global Star Party. Those of you that are watching later or watching now, even if it's bowling night and I have to sub for somebody, I generally don't want to miss Global Star Party. So here I am, and hopefully I did make a video. Maybe if I take the audio out, I'll just play the video.
Okay.
At some point in the future. And I do hope to make a couple other just video shorts and, do things. Just showing some of the stuff that I do, hopefully get some videos of me at some of these darker places. Sure. So looking forward to figuring that out and trying to keep it simple. And as always, I'll say it for you, Scott, for those of you that watch, we're glad to be back for the 114th Global Star Party. I know you heard from some heavy hitters, a couple of my friends, David Eicher, David Levy, David. You heard from Kareem Jaffer. You heard from the Astronomical League. And who else did we have on the A-list, Scott?
Everybody's on the A-list. David Levy, Carroll, president of the Astronomical League. Of course, you mentioned David Eicher, Navin, Senthil, Kumar, our astronomer. Daniel Barth from University of Arkansas. And we missed Maxi Falieres. He couldn't make it this time. John Schwartz, who you were commenting.
John Schwartz is my good buddy. He makes some very good drawings and is just. He's on fire for astronomy, and if there's ever an evangelist for astronomy, John Schwartz would lead. John Schwartz is the leader of the church. I mean, that's the Church of Astronomy.
Dr. Marcelo Souza was on.
I did. I watched that while I was bowling.
He doesn't like for me to call him doctor, but he does have a PhD.
He has a PhD.
He has one. Cesar Brollo, from Sirocco.
Yeah.
Dr. Franck Marchis from SETI was on, showing the
I'll have to rewatch that
mission
one
with the Unistellar telescope, their citizen science program, which is just amazing. And this guy called Adrian Bradley, who does all these amazing dark sky nightscape shots. So
I heard he should focus on that instead of all this bowling he's trying to do. Well, that's because he wants to go to Reno for the national at the National Bowling Stadium. There's a tournament that happens every year. I go with a coworker and several friends, and that's from there. I joined the Global Star Party, I think last year or the year before, to submit a photo of the lunar eclipse as it was happening. I barely caught it before we had to bowl. So I didn't do so well, but I felt complete because I got to see the total lunar eclipse from a parking garage rooftop in Vegas.
That. Yes.
So bowling never trumps astronomy. If we can't do one or the other, we do them both at the same time.
Right.
So that's how we do it. So hopefully those of you out there enjoyed Global Star Party, enjoyed the banner, the presentations, and I guess, Scott, we'll find out if we're able to do it again next week.
We will do it again next week. It's the 115th Global Star Party with the theme of attraction. Okay, so
that's going to be an interesting. That'll be an interesting one to think about. The law of attraction, you said. Or
just attraction.
Just attraction.
It is a major force in the universe. So.
Yes, it is.
Yep. All right.
All righty.
So I kind of screwed up earlier in the Global Star Party. I was showing this really interesting video from the people that put together the DART mission. And so I'm going to replay that video as we head on out.
Yeah, good night.
But Thanks again for making the time, Adrian. Thank you.
Always. I will take off. Those of you watching, enjoy the video. Scott, thank you for just having me on Global Star Party, even if I'm coming in wearing a bowling shirt.
No, that's cool.
I think my final series was somewhere close to, I think I averaged somewhere around 190 pins a game. So it's like a 190.
Wow.
So it wasn't too bad today.
That's really good. Much better than
Yeah.
me. I'm throwing gutter balls all the time. So
Well, just have to keep having fun. And if we just have fun and keep, after bowling's over, just go outside and look up. You'll always feel better.
That's right.
That's my advice for all those still watching. And thank you all for joining us, and we'll see you next week.
All right. Take care.
All righty. Bye.
Welcome to another installment of Inside the DART Mission. I'm Mike Buckley from APL Communications, and we are at the Planetary Impact Lab at the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland. And I'm with APL planetary scientist Angela Stickle. Angela,
Hello.
I guess, welcome. And first, let's even just start right away with, what's your role on the DART mission?
I am the impact modeling working group lead for DART, so I lead up all of the simulations of the actual impact to try to understand what will happen after we hit Dimorphos.
Okay, so we're talking about impacts.
Talking about impacts.
Is there a better place to talk about impacts than in the Planetary Impact Lab?
Probably not.
Tell us what happens here.
So in this lab, we have a couple of different things. We study impact processes around the entire solar system. So we have a vertical gun range where we can test impacts into different types of targets. So we can use sands or ices or different types of rocks to mimic planets and asteroids and try to understand what happens when an asteroid or something like DART hits them to understand the cratering process. This is our ejecta catapult, so it's the second main part of our lab, and it is designed to mimic all of the debris that gets thrown up in an impact crater as it travels away from the crater and hits the surface. So we have a catapult here, and you can load material, so sand, or we like to use aquarium gravel actually. The bright colors make it easy to track. Onto this, you pull it back, and then you throw it. So we're literally throwing dirt across the room to see how it moves through the air and to see how it interacts on the surface.
So why is that so important? I mean, why do we need to know that information?
So impacts happen all over the solar system, and they happen all the time. They're sort of the most prevalent process that we see on planetary bodies. And they happen really, really fast. It's not something that you can just walk around and see. And so it's hard to understand the physics of what goes on. And so you need to have laboratories like this, specialized cameras and specialized equipment, so you can actually understand the physics of what happens, to understand the geology that we see, but also to predict things.
Now, we see things in movies all the time. I mean, like say that happens too fast, right? In movies, it's all slow, right? We're watching these big things come flying in, and it hits this big impact. But you're talking about impacts of all different sizes, maybe not just larger ones, but even smaller ones, tiny ones that you see to make sure what happens on the surface when something hits.
Yeah, so small things like pieces of dust or small like pieces of paint from spacecraft or something like that can cause damage. They can cause impact craters if they hit like the space station or they hit a satellite and create craters just like we see on planets with the big stuff. So it's important to understand this sort of at all sizes.
Why is modeling and simulation then so important for the DART mission?
So for a couple of reasons. So DART is the first planetary defense mission that's ever been flown. And it's really a test, right? It's right in the name, Double Asteroid Redirection Test. We don't actually know for sure exactly what's going to happen because we've never done it before. And so modeling gives us sort of that best picture of what to expect. It lets us design the mission in a way so that we can be successful. So we did a lot of simulation early on to understand kind of what size of spacecraft might you need or what velocities might you need to hit at. We also don't know a lot about Dimorphos, right? Every time we go to a new asteroid, it's different than all of the other asteroids that we've been to. And so depending on what Dimorphos looks like, the results of DART could be different. And so modeling lets us see kind of all of those different options so we have a better sense of what to expect and also then to back out what happened afterwards. It tells us, if we see X and the model tells us in order to get X, you had to have A, B, and C happen. It lets us know what happened when we can't be there in person to watch it.
So it sounds like we're trying to learn a few things from the DART mission. mean, it's not just what happens with the spacecraft when it hits an asteroid, but even the properties of an asteroid too. It sounds like there's a couple of things we're trying to learn from this mission.
Absolutely. So DART, obviously, its primary purpose is to teach us about planetary defense and the effectiveness of this technique called the kinetic impactor. And so DART is going to teach us a lot about that. We think we know what's going to happen, but my favorite part of experiments is, when you think you know what's going to happen and then it doesn't happen exactly that way, you learn something. But yeah, also going to teach us about the asteroid. So depending on what Dimorphos is made of, depending on if we see lots of boulders or if it's very fine grained like sand, or maybe it's just one big boulder in space, all of those things will cause something different. They'll cause a different crater to form. They'll cause a different ejecta curtain that we can see with Eicher cubed, and so it can teach us a lot about what it's made of after the fact.
I mean, the large focus of DART obviously is the impact. Yes. I remember we're going to crash a spacecraft into an asteroid, but you mentioned a couple of other things here too. So, I mean, what do you think is the most interesting thing about the DART mission?
I mean, the impact is, I think, so I'm an impact nerd, so the impact is definitely one of my, I think it's going to be really interesting, but my favorite, like I said, my favorite part about any experiment is being wrong. So I think the most interesting thing is going to be when all of my models turn out to be wrong. Like, I'm actually really excited about that because I think that is when you learn the most.
Yeah.
Right? You think, I know what's going to happen, I know all of these things, and then something totally new happens. To be fair, I think we're going to create a crater, we're going to change the period of Dimorphos. I think all of that is going to happen. But I think maybe the amounts or what we learn about the material properties that we had thought of ahead of time is not going to be true.
Yeah, I mean, right. Who would want to think too, like, prove me wrong, right? But that's the essence of science too.
Yeah.
I mean, be able to actually try this, which made me think about what's the most important aspect, what's so important about missions like DART and planetary defense to do these?
So really, I think for me, it's the scale, right? We have this lab, it's awesome. We can do impact experiments, I can simulate them with my models, but those are all really small scale things, right? When we fire projectiles in our gun range, they're like 1/4 of an inch. They're tiny, right? Asteroids are big. They're hundreds of meters, they're kilometers. And so being able to actually get that data point that says, yes, you can go from your experiments in your lab up to reality is really, really important. You can only get that by doing these sort of planetary scale space missions.
Right, some way to get it off the screen, off paper, out of the lab, and into the real environment to actually see it happen.
Yeah.
Okay, so for an impact nerd, right, and from the science aspect of this, what's the most interesting thing about DART, about the fact that you're going to have this up-close involvement with an asteroid?
So I think it's going to be what it teaches us about the cratering process on asteroids, because asteroids are kind of weird. What we learned when we took samples at Bennu and Ryugu is like the surfaces, they're not what we thought they were. You've got these boulders, you have these spots that are just kind of sandy, they're really, really weak. So if you were to walk on them, you might sink, instead of just, it's really strange. And so I think just understanding how that changes the impact process is really important, because that then teaches us later on, if heaven forbid an asteroid were actually coming towards the Earth, it tells us how to better protect ourselves. Plus, it's just cool science.
Yeah, I'm even looking at the pictures behind us here, and these are all different asteroids that we have visited with spacecraft, and look how different each one of them is.
They're all very different.
So even to get this one instance of how one works is incredibly valuable.
Oh yeah. And as you say, they're all different, and every time we go to a different asteroid, we learn something new. And then this will be another data point. This is going to be one of the smallest ones we've ever visited up close. We're going to have these amazing pictures as DART comes in of the surface, and so that'll be just brand new things that we've never seen before.
We've covered a lot here too, but is there anything I didn't ask, or is it just something you want to add?
Yeah, I mean, I guess to reiterate, it's so important to do these tests at scale. Right? We've only done this a couple of times. We've only had a couple of other space missions that purposefully impacted things. We had Deep Impact, we've had L-Cross, and we learned so much from them. And just having these tests at the real scale that teach us the real physics is so important for science, but also for future planetary defense. So DART is so exciting because it's going to give us that data point that we can point to if we need it in the future to extrapolate to other potentially hazardous objects or other asteroids when we're working to protect humanity from space.
And we're all going to be watching that too, as those keep coming in too.
Yes.
So, well, thank you, Angela, and thank you for joining us. Again, I'm Mike Buckley and Angela Stickle. Go Dart.
And thank you again to our audience. For any of the presenters that are still watching out there, thank you very much. And tune in next week, next Tuesday, 14th of March at 6 p.m. Central for the 115th Global Star Party with the theme of attraction. So until that time, keep looking up, and we'll talk to you soon. So it's a beautiful sunny day, and we have our refractor out, and I've got my eclipse glasses on, and I've got my safe solar filter. Of course, the eclipse is not here yet, but I wanted to take a few minutes just to show you some things about solar filter safety. The filters that we use is the Thousand Oaks material. It is rated to the highest ISO standards. And actually independently tested by us as well. So just to make sure that those standards are met. So if you're going to use a telescope to look at the partial phases, and let me underline partial phases to you, you use eclipse glasses to observe the sun in partial phases when it's in total. If you're going to be on the path of totality, you can take the glasses off, and only during that time, which is going to be roughly 2 minutes this time on August 21st, only during that time can you directly look up at where the sun is, because it's completely blocked out. You'll see the corona, you'll see, lots of really cool effects they'll leave you speechless. But during all the partial phases, you have to have safe solar filtration. So how do you do it properly? Let me show you. First off, let's show you what you shouldn't do. What you shouldn't do is put on eclipse glasses and look through the telescope that's unfiltered. And I'll show you exactly why here. We're going to point the telescope directly at the sun. And right now, we have sunlight coming right through the eyepiece. You know, I can turn that up a little bit. If you use solar glasses and look right at the filter material, you see it's already burning. It's burning a hole right through the solar filter material. That is how powerful a telescope is. So this is definitely something you don't want to do. You can now see that there is a hole through there, and that could be your eye. So this is what can happen if you think that you can use eclipse glasses to look through unfiltered telescopes or binoculars. If you do that, the sun's energy is going to burn right through the filter and burn right into your eye. So if you're going to use a telescope or a pair of binoculars to watch the partial phases of a total eclipse, or just to observe the sun to look for sunspots or something like that, make sure that you are using an over-the-lens solar filter that has the proper ISO safety rating and all of that. And so what I'm going to do is I'm going to put this filter on. It's you can see how snugly it's fitting here. This is not about to come off, but you know, if you have a loose-fitting filter, use tape. Do anything that you can to make sure that the filter is not going to come off. And then the other thing is too is that finder scopes, optical finder scopes are like little telescopes, and they need to be filtered as well. In this case, I just have a red dot finder. There is no magnifying power to it, so I'm not going to use it to sight the sun in. The way I'm going to sight in the sun is literally as I'm going to look down at the shadow and align the scope up so I'm getting the smallest shadow possible of the telescope as it's hitting the ground. And now I can safely look at the sun in comfort and look at sunspots, and if we have partial phases going on in the eclipse, I'll see them all.